Creating millions of Almond Joy bars every day takes a perfectly synchronized process of speed and sweet engineering. Inside high-tech factories, coconut is shredded and coated in smooth chocolate, all in a matter of seconds. In this documentary, we take you behind the scenes to uncover the fascinating journey of how this iconic candy bar is mass-produced. Manufacturing Almond Joy candy bars on an industrial scale begins long before any chocolate is melted or coconut is mixed. It starts with the careful sourcing and preparation of one of the candy's most iconic and defining components, the coconut. This isn't just any shredded coconut. This is a specific, moisture-balanced, finely textured variety that gives Almond Joy its distinct chewy center. Producing coconut to these specifications requires a highly controlled and deliberate process. And in modern facilities, this step alone involves extensive coordination between agricultural suppliers, food scientists, and processing engineers. The coconuts used in Almond Joy bars are primarily sourced from tropical regions like the Philippines, Indonesia, and India, where coconut palms grow in warm, humid climates and are harvested multiple times per year. The coconuts are selected based on strict criteria such as maturity, size, and oil content, all of which contribute to the flavor and structure of the final product. After harvesting, the outer husks are mechanically removed using rotary dehusking machines, exposing the inner brown shells. These shells are then cracked open using high-torque hydraulic presses or mechanical splitters, allowing access to the white coconut meat inside, also known as copra. Once separated from the shell, the coconut meat is washed in large stainless steel tanks using filtered water, sometimes with a light chlorine solution to remove any contaminants, shell fragments, or residual dirt. The clean coconut meat is then graded using high-speed rotary shredders, which reduce it into uniform strands. These industrial shredders operate at several thousand RPMs and are fitted with specialized blades designed to achieve a consistent flake size. The exact dimensions of the shredded coconut are critical. Too coarse, and the texture becomes stringy. Too fine, and it loses its chewiness. The shredded product is then passed through vibratory sieves to remove any oversized or undersized particles, ensuring each flake meets factory specifications. Once the coconut is shredded and sized, it undergoes a drying phase designed not to fully desiccate the coconut, but to bring its moisture content into a very specific range, typically between 12 and 14%. This drying process is carried out in large belt dryers or fluidized bed dryers that blow heated air over the coconut shreds while keeping them suspended and moving, ensuring even drying throughout. Sensors embedded in the dryer constantly monitor moisture levels in real time, allowing for micro adjustments to airflow and temperature. This precision ensures that the final coconut retains its soft, moist chewiness without being wet or prone to microbial spoilage. Once dried, the coconut is cooled with ambient air and sent through a metal detection system before being packed into sterile bulk totes or drums, ready to be delivered to the candy production line. Now it's time to go into the coconut syrup blending process, where the prepped coconut is transformed into the moist, sweet filling that forms the base of every Almond Joy bar. At this stage, the dried coconut shreds are transferred from storage bins into large stainless steel ribbon blenders or planetary mixers. These mixers are food grade and designed to gently fold the ingredients together without compressing or overworking them, which would damage the texture. While the coconut is being added to the mixer, a separate part of the factory is simultaneously preparing a sugar syrup that will serve as the binder and sweetener. This sugar syrup is cooked in large steam-jacketed kettles, each fitted with agitators and temperature sensors. The syrup typically contains a blend of sucrose, corn syrup, and a small percentage of invert sugar, which helps prevent crystallization and keeps the final mixture smooth and cohesive. The ingredients are combined with water and brought to a boil, then held at a precise temperature of around 230 to 240 degrees Fahrenheit. Once the syrup reaches the desired consistency and viscosity, it is pumped through insulated transfer lines into the mixers containing the shredded coconut. The hot syrup is slowly added into the mixing chamber while the paddles rotate at a controlled speed, ensuring that every strand of coconut becomes evenly coated. This mixing step is closely monitored for torque resistance, an indirect measure of viscosity and saturation. If the mixture becomes too stiff, it indicates that not enough syrup has been added, while an overly slack consistency could suggest too much moisture. Adjustments are made in real time, either by slowing down the mixing blades or by adding additional syrup in carefully measured quantities. The end result is a glossy, dense, and aromatic coconut mixture with a smooth mouthfeel and a controlled stickiness that allows it to hold together when molded. This freshly prepared filling is discharged from the mixer into temperature-controlled holding hoppers. From there, it is fed through sanitary auger systems into the forming line, where the next phase of production begins, shaping each bar's core. But up next is the forming process, where this cohesive coconut mixture is portioned and molded into the rectangular log shape that defines the inner core of every Almond Joy. This step is handled by a specialized extrusion and forming system. The mixture is continuously extruded through a die system that determines the width and height of the log. These forming dies are custom designed for Almond Joy and produce a consistent cross-section with slightly rounded tops, ensuring a uniform bite and a reliable surface for almond placement. The extrusion head releases a continuous ribbon of coconut mixture onto a moving conveyor belt, and a high-speed rotary guillotine, timed with the conveyor's speed, cuts this ribbon into individual bar-length pieces. The distance between each cut is controlled down to the millimeter, and a sensor-based feedback system ensures that every bar is exactly the same size. After cutting, a short air blast is applied to each log to clear away any stray coconut flakes and ensure clean edges. As the bars are cut, they enter a cooling conveyor that travels through a tunnel kept at approximately 45 degrees Fahrenheit. The cooling process is essential at this point. Not only does it help the bars hold their shape, but it also stabilizes the sugar syrup binder so that the mixture doesn't slump or deform in the next step. A key consideration during this cooling stage is air humidity. If the environment is too dry, the coconut can begin to crust or dry out. Too humid, and condensation may form, which can affect downstream adhesion with the chocolate coating. For this reason, industrial humidity control units maintain relative humidity levels around 45 to 55% inside the cooling tunnel. Once cooled and firmed, the coconut logs are transferred by conveyor to the almond placement system. Each log must receive exactly 2 whole almonds, neither more nor less, positioned evenly across the top surface. The almonds used in this process are themselves the result of a careful preparation sequence. Raw almonds are sourced from large-scale growers, often in California, and are received at the factory in bulk containers. These almonds are sorted, cleaned, and then dry roasted in large convection ovens. Roasting enhances flavor, reduces moisture to less than 5%, and gives the almonds the crunch consumers expect. After roasting, the almonds are cooled and transported to a hopper above the placement system. Here, they are singulated, separated into single file, and guided into individual almond placement arms. These arms are controlled by a vision-guided robotic system that tracks the position of every coconut log in real time. Using photoelectric sensors and high-resolution cameras, the system places each almond with millimeter-level accuracy on top of the log. The almonds are pressed into the surface just enough to adhere without sinking, and an inline inspection system checks that every bar has precisely 2 almonds aligned correctly. Any bar that deviates from this standard is removed from the line for manual inspection or rework. Now it's time to go into the chocolate enrobing stage, which marks the beginning of the transformation from a basic assembly of ingredients into the finished, glossy, consumer-ready candy bar. This process involves fully coating the almond-topped coconut cores with a layer of milk chocolate. But this is no ordinary chocolate. It has been specifically formulated and tempered to provide the right snap, shine, and melt-in-the-mouth texture that defines the Almond Joy eating experience. The chocolate is stored in holding tanks maintained at 110 to 115 degrees Fahrenheit and stirred continuously to ensure it remains fluid and free from separation. Before use, the chocolate is tempered through a process that heats, cools, and reheats it to align the cocoa butter crystals in a stable form. Proper tempering is essential as it prevents fat bloom and gives the coating its glossy finish and clean break. The tempered chocolate is pumped into an enrobing machine, which dispenses it in a continuous curtain across the width of the conveyor belt. As the coconut and almond cores pass underneath, they are fully submerged in the falling sheet of chocolate, while a bottoming unit applies a layer of chocolate to their underside. Immediately afterward, a series of air blowers remove excess chocolate, ensuring a uniform thickness and revealing the shape of the almonds beneath. What emerges is a fully coated bar that looks and feels like the final product, but still needs time to set. That step begins as the bars enter a temperature-controlled cooling tunnel, and that's where the next phase begins. Inside the cooling tunnel, a meticulously engineered, climate-controlled chamber extending over 30 feet in length, the freshly enrobed Almond Joy bars begin their chocolate setting phase. This tunnel is one of the most crucial parts of the process, ensuring that the tempered chocolate coating transitions from a glossy liquid into a solid shell with the perfect texture and finish. The chocolate must cool at a precise rate, not too fast, which could result in cracking or sugar bloom, and not too slowly, which could cause the cocoa butter crystals to misalign, leading to dullness or fat bloom on the surface. The tunnel operates at an ambient temperature between 45 and 55 degrees Fahrenheit, and relative humidity is tightly controlled around 50%. High-efficiency fans circulate cold air evenly across all bars on the conveyor, and temperature sensors track minute variations along the length of the tunnel. The speed of the conveyor is carefully synchronized with the chocolate's crystallization curve so that the bars spend just the right amount of time cooling, usually between 7 and 12 minutes, depending on environmental conditions, line speed, and chocolate thickness. During this stage, the chocolate coating fully hardens around the coconut and almond core, creating a glossy, smooth outer layer that locks in moisture and flavor. The almonds, having been gently pressed into the top of the coconut before enrobing, remain clearly visible through the chocolate shell, creating the bar's iconic bumpy silhouette. As the bars exit the tunnel, they are now fully formed, with all primary ingredients integrated and stabilized. But the next phase, inspection and quality control, ensures that only perfect bars make it into the hands of consumers. The next step is the multi-layered inspection and quality assurance phase, a critical junction in the Almond Joy manufacturing process. Here, each fully cooled, enrobed bar passes under a series of digital scanning systems equipped with high-resolution cameras and sensors that detect inconsistencies in shape, size, and appearance. These systems analyze every bar in real time using image recognition algorithms trained to identify surface defects, incomplete chocolate coverage, missing almonds, or any signs of misalignment. Each camera system captures dozens of images per second, creating a detailed digital fingerprint of each bar. If a defect is detected, such as an air bubble on the surface, a chocolate smear, or a misaligned almond, the bar is automatically rejected using a quick puff of compressed air that directs it off the main conveyor into a designated collection tray, Rejected bars are recorded and analyzed in quality control logs to monitor trends and flag any upstream issues in real time, like syrup inconsistencies or almond placement variances. Following the visual inspection, the bars pass through an inline check weighing station. This precision balance system measures the mass of each individual bar down to the 1/10 of a gram. Bars that are even slightly under or overweight are flagged and rejected from the line. This strict weight control not only ensures product consistency and consumer satisfaction, but also regulatory compliance, as all packaged goods must meet labeled net weight declarations. These check weighers are recalibrated frequently during production to maintain absolute accuracy, and the results are logged digitally to provide traceable batch records. Next, a random sampling process is initiated where trained human inspectors pull sample bars from the line every few minutes. These samples are taken to a nearby quality assurance room for deeper evaluation. Inspectors slice open the bars and examine the cross-section for proper ingredient distribution, moisture retention in the coconut layer, almond placement, and shell integrity. Taste testing is performed by a trained sensory panel in a separate tasting room to ensure the flavor profile remains consistent. Parameters like sweetness, chewiness, and chocolate snap are all evaluated and recorded in a detailed quality report. Once bars have successfully passed through the inspection phase, they are ready for the next stage, packaging. But up next is the flow wrapping process, where each Almond Joy bar is individually wrapped using high-speed machinery designed to maintain hygiene, preserve freshness, and uphold branding consistency. The packaging film, pre-printed with the Almond Joy logo and product information, is loaded in giant rolls at the start of the packaging line. These rolls are threaded through a series of rollers and tensioners that keep the film aligned and taut as it's fed into the wrapping unit. The bars are spaced and synchronized onto a conveyor lane and fed into the flow wrapping machine, which envelopes each one in film and seals it at the sides and ends using heated crimping jaws. These jaws press the film together and apply controlled heat and pressure to create airtight seals that are strong yet easy to open. The sealing temperatures are carefully monitored to avoid overheating the chocolate within, as excess heat could cause the surface to dull or soften. Each wrapped bar is then passed under a thermal inkjet or laser coder, which prints the best before date, batch code, and production time directly onto the wrapper. This traceability information is vital in case of recalls, inventory tracking, or shelf life analysis. Vision sensors verify the presence and clarity of the code, and any missing or illegible codes trigger a rejection mechanism. The speed of this entire process is remarkable. Modern flow wrappers can handle upwards of 500 bars per minute, all synchronized perfectly to match the upstream enrobing output. Once wrapped and coded, the Almond Joy bars are grouped into retail-ready formats. Depending on the destination, this could mean twin packs, king-size versions, or standard singles in cartons. Cartoning machines fold and glue cardboard sleeves or cartons, then insert the correct number of bars automatically. These cartons are scanned for correct orientation, closed, and labeled with shipping and SKU data. A final check weigher ensures that the total weight of each carton falls within specification, and the completed units are then moved down the line to case packing. The case packing phase involves automated robotic arms or pick-and-place systems that lift finished cartons and place them into larger, corrugated shipping cases. The arrangement within each case is optimized for pallet stability and protection during transit. Each case is labeled with product identifiers, batch codes, and destination information, then sealed and conveyed to a palletizing station. Palletizing robots stack the cases onto wooden or plastic pallets in precise configurations to maximize space and maintain structural integrity during transport. Once a full pallet is assembled, it's wrapped in high tensile stretch film using automated rotary arm or turntable wrappers. This wrapping secures the load against shifting during transportation and also provides a barrier against dust and moisture. Each pallet is then tagged with a barcoded shipping label that includes tracking information, weight, and customer-specific handling instructions. The completed pallets are moved to a climate-controlled storage area within the warehouse to await shipment. Now, it's time to go into the logistics and distribution stage, where the focus shifts from production to coordinated movement and inventory management. Almond Joy bars, like all Hershey's products, are managed within an enterprise resource planning system that tracks production batches, inventory turnover, and customer orders in real time. Based on demand forecasts, pallets are selected for outbound shipment, assigned to specific trucks or containers, and scanned out of the warehouse with full digital traceability. Transport is typically handled using refrigerated trucks during warmer months, as the milk chocolate in Almond Joy bars is sensitive to heat. Temperatures are maintained between 55 and 65 degrees Fahrenheit during transit, and GPS-linked thermal loggers monitor each vehicle's internal climate from origin to delivery. If a truck deviates from its safe range, alerts are sent to both logistics managers and warehouse supervisors to prevent spoilage. Once the bars reach regional distribution centers or retail warehouses, the product is scanned into inventory and routed to store shelves. Retail partners rely on synchronized inventory systems that replenish stock as it sells, often based on point-of-sale data. The entire journey, from coconut grove to grocery store, can be completed in just a matter of weeks, but every phase must function flawlessly to deliver a bar that meets Hershey's standards for quality, freshness, and consistency. And even once the product hits shelves, the factory's job isn't done. Ongoing consumer feedback, seasonal demand changes, and promotional cycles influence continuous adjustments in batch sizes, production schedules, and packaging variations. Special holiday versions, multi-packs, and limited time offers are all planned months in advance and require tailored processes, new molds, and reprogrammed machinery, an impressive level of flexibility embedded within an otherwise standardized production system. Quality assurance continues to play an active, ongoing role in the manufacturing of Almond Joy, even after the bars have been wrapped, packed, and prepared for distribution. In fact, behind the scenes of the main production line, a parallel infrastructure operates continuously to monitor, record, and validate every element of the process in real time and long after the initial production phase. This includes not only in-process checks, but detailed post-production sampling and retention, which are central to traceability, regulatory compliance, and product consistency. One critical ongoing practice is the archiving of batch samples. As bars are wrapped and prepared for shipment, dedicated staff routinely pull random samples from each batch, often one every few thousand bars. These samples are sealed, labeled, and logged with all relevant metadata: the exact time of production, line number, raw material codes, chocolate viscosity at time of enrobing, coconut moisture content, and even almond roast profiles. These reference bars are stored in secure, climate-controlled storage units maintained at conditions that mimic ideal shelf environments. The goal is to preserve these products in a stable state for up to 2 years, during which time they may be retrieved for comparison if any quality concerns or deviations arise. In addition to acting as an insurance policy against customer complaints or distributor queries, these archived samples are regularly tested as part of long-term shelf life studies. Trained quality assurance technicians perform controlled aging studies by artificially accelerating the aging process in heated chambers to evaluate how the product will hold up over time. These studies track changes in coconut chewiness, chocolate bloom resistance, almond crunch retention, and overall flavor integrity. Sensory analysis is conducted by expert panels who evaluate sweetness, aroma, textural contrast, and mouthfeel using standardized scoring systems. This data feeds back into ingredient sourcing decisions and packaging refinements, allowing the team to adjust variables well before any potential issues could reach consumers. Now, it's time to go into the digital control systems that operate silently beneath every piece of equipment, coordinating, recording, and adjusting every stage of the Almond Joy production process. At the core of this system is a network of programmable logic controllers, PLCs, which manage the real-time operation of machinery across the factory floor. These industrial computers are programmed to respond to sensor inputs and control outputs with extreme precision, enabling the synchronization of critical events such as syrup dosing, coconut extrusion, chocolate tempering, and wrapper sealing. For example, if the syrup temperature in the blending kettle falls even slightly below the optimal range of 235 to 240 degrees Fahrenheit, the PLC will automatically trigger a compensatory adjustment in steam pressure. Similarly, if a sensor detects that the chocolate curtain in the enrober has begun to thin, indicating an issue with flow rate or chocolate viscosity, the system can alter pump speed, activate an agitator, or send an alert to the line technician. These reactions happen in milliseconds, ensuring seamless operation with minimal human intervention. All this data funnels into a supervisory control and data acquisition system, or SCADA, which acts as the digital nervous system of the plant. SCADA systems provide centralized visualization of every variable in production, from torque readings in the coconut mixes to conveyor belt speeds on the packaging line. Live dashboards display real-time metrics alongside historical trends, and operators can set control limits to trigger alarms, shutoffs, or automatic corrective actions when deviations occur. Data logging is continuous, with every action time-stamped and stored in redundant backups for audit and analytics purposes. But up next is the role of continuous improvement teams and how they use this wealth of production data to fine-tune the manufacturing process. Rather than viewing each shift as a discrete operation, modern Almond Joy factories treat every minute of production as a learning opportunity. Statistical process control specialists and lean manufacturing engineers analyze massive volumes of data to identify small but significant trends. For instance, if there's a subtle uptick in the rate of chocolate flow variation on line 2 during evening shifts, it might suggest thermal drift in the tempering unit or minor calibration errors in the chocolate pump. These insights allow preventive maintenance schedules to be updated, saving time and resources while minimizing the risk of future disruptions. Some adjustments are made on the spot, while others lead to full pilot testing cycles. Pilot lines, scaled-down versions of the full production setup, allow engineers to test adjustments to temperature profiles, mixing durations, or conveyor speeds without interrupting primary operations. For example, if a new batch of coconut arrives with slightly higher fat content than normal, the pilot team may experiment with modified syrup ratios or mixing times to maintain the same moisture binding characteristics. Results are measured using laboratory tools like refractometers, rheometers, and moisture analyzers. And the most successful configuration is then rolled out to full production. The focus on fine-tuning doesn't stop at equipment and ingredients. It also extends to the behavior of the product throughout the supply chain. Some Almond Joy bars are shipped across the country or even internationally, and that means packaging and formulation must perform under a wide range of conditions. Engineers perform transit simulations using vibration tables and thermal chambers to replicate the effects of long-distance trucking or air freight. These simulations allow packaging specialists to evaluate wrapper integrity, seal strength, and chocolate stability under heat and motion stress. In cases where performance can be improved, new materials or layering structures are proposed, often months before the consumer ever sees the final package. Hershey's chocolate bars begin their journey long before they ever reach a factory. It all starts with the cocoa bean, the essential ingredient that gives chocolate its signature taste. Cocoa trees grow in the tropical regions of West Africa, South America, and Southeast Asia, where warm temperatures and high humidity create the perfect environment for cacao cultivation. Farmers carefully harvest ripe cocoa pods, slicing them open to extract the cocoa beans nestled inside. These beans are then piled into large heaps or wooden boxes, where they undergo fermentation, a crucial process that develops the deep, complex chocolate flavors. Over several days, the beans are stirred occasionally, allowing natural yeast and bacteria to work their magic. The result is a transformation from bitter, raw cocoa to something much closer to the chocolate taste that will eventually be refined and perfected in Hershey's factories. Once fermentation is complete, the cocoa beans are spread out under the sun to dry. Farmers rake them periodically to ensure even drying, preventing mold growth and preserving the beans' quality. This drying process can take up to a week, depending on weather conditions. When fully dried, the beans are packed into burlap sacks and shipped across the world to Hershey's chocolate production facilities. The journey from farm to factory is carefully monitored, as the quality of the beans at this stage will significantly influence the final product's taste and texture. Upon arrival at the Hershey factory, the cocoa beans go through a strict quality control process. They are first inspected for size, color, and overall condition. Any beans that do not meet the company's rigorous standards are removed from the batch. Next, the beans are thoroughly cleaned to remove any dust, dirt, or foreign matter that may have accumulated during transport. High-powered air jets and mechanical sifters separate unwanted debris, ensuring that only pure cocoa beans proceed to the next stage. Once cleaned, the cocoa beans move into the roasting phase. Roasting is one of the most important steps in chocolate production, as it intensifies the flavor and brings out the rich, aromatic notes associated with Hershey's signature taste. The beans are poured into large rotating drum roasters, where they are exposed to controlled heat for a specific duration. The precise temperature and roasting time are carefully calibrated based on the desired flavor profile. As the beans roast, their moisture content decreases, and chemical changes occur within the beans, developing the characteristic chocolatey taste. The air inside the roasters is constantly circulated to ensure even roasting, and sensors monitor the temperature to maintain consistency. Once the beans have been roasted to perfection, they are transferred to the winnowing machines. Here, the beans are cracked open, breaking them into smaller fragments called nibs. The outer shells, which are no longer needed, are blown away using air currents, leaving only the rich, flavorful cocoa nibs behind. These nibs contain the essence of chocolate, and they will soon be transformed into a smooth, creamy liquid that serves as the foundation for Hershey's chocolate bars. Meanwhile, another critical ingredient in Hershey's chocolate is being prepared: milk. One of the distinguishing features of Hershey's chocolate is its unique milk treatment process, which contributes to its recognizable flavor. Fresh milk is sourced from dairy farms located near the Hershey factory to ensure freshness. Upon arrival, the milk undergoes pasteurization, a heating process that eliminates harmful bacteria while preserving its nutritional qualities. The milk is then condensed and mixed with sugar, creating a rich, sweetened milk base that will later be combined with the cocoa ingredients. As the cocoa nibs continue their transformation, they are sent to grinding machines, where they are crushed into a thick, liquid paste known as chocolate liquor. Despite the name, chocolate liquor contains no alcohol. It is simply the finely ground form of cocoa solids suspended in cocoa butter. The grinding process generates heat, which helps break down the cocoa particles even further, creating a smooth consistency. The quality of this chocolate liquor is crucial, as it will determine the texture and taste of the final chocolate product. Once the chocolate liquor is ready, it is blended with the sweetened condensed milk mixture, along with additional cocoa butter and sugar. These ingredients come together in large industrial mixers where they are thoroughly blended to create a uniform chocolate mixture. The goal at this stage is to ensure even distribution of flavors, so the chocolate undergoes multiple rounds of mixing and refining. The refining process is carried out using heavy steel rollers, which reduce the particle size of the chocolate to an ultra-fine consistency. This step is essential for achieving the smooth texture that Hershey's chocolate bars are known for. After refining, the chocolate mixture moves into the conching phase, a process named after the shell-like shape of the original conching machines. Conching involves continuously churning and aerating the chocolate for several hours, helping to develop a silky texture and deepening the flavor. The friction generated by the conching machines warms the chocolate slightly, allowing undesirable acidity and bitterness to dissipate while enhancing the overall creaminess. Hershey's carefully controls the conching process to achieve a balance of flavors that has remained consistent for over a century. Once conching is complete, the chocolate is not yet ready to be molded into bars. It must first undergo tempering. Tempering is a delicate process that involves heating and cooling the chocolate in a precise manner to stabilize the cocoa butter crystals. If chocolate is not properly tempered, it can develop a dull appearance, a grainy texture, or white streaks known as bloom. To prevent this, Hershey's employs advanced tempering machines that carefully regulate the temperature changes, ensuring that the chocolate maintains a glossy finish and a firm, satisfying snap when broken. With the chocolate now perfectly tempered, it is ready to be molded into the iconic Hershey's chocolate bar shape. Liquid chocolate flows into custom-designed molds that feature the signature rectangular segments, each embossed with the Hershey's logo. These molds travel along a conveyor belt through a cooling tunnel, where the chocolate gradually solidifies. The cooling process is precisely controlled to ensure even crystallization, which contributes to the final bar's smooth texture and structure. Once the chocolate has fully set, the bars are carefully removed from the molds and inspected for any imperfections. While the chocolate bars are being formed, the packaging materials are also being prepared. Hershey's chocolate bars are wrapped in a combination of foil and paper, a packaging style that has remained largely unchanged for decades. The foil wrapping helps protect the chocolate from moisture and light, preserving its freshness and preventing it from developing off flavors. The outer paper wrapper, printed with the familiar Hershey's branding, serves as both an aesthetic and informational component, providing details about the product while reinforcing the brand's legacy. As the tempered chocolate flows through the production line, it is maintained at an exact temperature to prevent premature setting. Hershey's factories employ state-of-the-art computerized systems that regulate every aspect of the chocolate's movement, ensuring that the liquid chocolate maintains the ideal viscosity. If the chocolate is too thick, it may not fill the molds evenly. If it is too thin, it may not develop the proper texture once solidified. To maintain this delicate balance, specialized flow control pumps continuously circulate the chocolate through insulated pipes that keep it warm and fluid until the exact moment it is deposited into the molds. The molds themselves are engineered with extreme precision to create the uniform shape and smooth surface that Hershey's chocolate bars are known for. Each mold is made from food-grade polycarbonate material, designed to withstand repeated use while maintaining an ultra-smooth interior that ensures the chocolate releases cleanly once set. These molds travel along a high-speed conveyor belt system, positioned beneath nozzles that dispense the precise amount of liquid chocolate needed to form each bar. Advanced sensors monitor the filling process, making real-time adjustments to ensure that every mold receives an identical amount of chocolate. Once the molds are filled, the next critical step in the process is vibration. The conveyor belt moves the freshly filled molds to a specialized vibrating platform, which gently shakes them at a controlled frequency. This step serves two important purposes. First, it helps remove any trapped air bubbles that could create holes or uneven textures in the final product. Second, it ensures that the chocolate settles evenly within the mold, creating a smooth and uniform appearance. Even the slightest inconsistency in this stage could lead to defects in the bars, so Hershey's quality control team continuously monitors the process to maintain consistency. After vibration, the molds enter a cooling tunnel, a long temperature-controlled chamber that gradually reduces the chocolate's temperature to encourage proper crystallization. This step is crucial for achieving the perfect texture and preventing unwanted fat bloom, which can occur when cocoa butter crystallizes improperly, resulting in a white, powdery appearance on the surface of the chocolate. The cooling tunnel is divided into multiple temperature zones, allowing the chocolate to solidify gradually rather than cooling too quickly, which could cause structural weaknesses or affect the snap of the final bar. As the chocolate sets, it undergoes another round of automated inspection to detect any irregularities. High-resolution cameras and laser scanners analyze each mold, checking for inconsistencies in shape, texture, or surface quality. Any bars that do not meet Hershey's exacting standards are rejected and sent back for remelting, ensuring that no chocolate goes to waste. Once the bars pass inspection, they are gently removed from the molds using an automated demolding system. A combination of slight flexing and compressed air helps separate the bars from the molds without damaging their delicate structure. Now that the chocolate bars have taken their final shape, they must be prepared for packaging. Hershey's packaging process is one of the most sophisticated in the confectionery industry, designed to ensure that each bar remains fresh and protected from environmental factors such as moisture, temperature fluctuations, and physical damage. The first step in packaging involves a high-speed wrapping machine that envelopes each bar in a layer of aluminum foil. This foil serves as a crucial barrier against light and oxygen, both of which can negatively impact the flavor and quality of the chocolate over time. Once the bars are wrapped in foil, they move to the next stage, where the outer paper wrapper is applied. Hershey's iconic packaging, with its bold brown and white branding, is instantly recognizable and has remained largely unchanged for decades. The wrapping machine applies a thin bead of adhesive to secure the paper wrapper in place, ensuring that it remains tightly sealed around the foil-covered chocolate bar. Automated sensors check each wrapped bar for proper alignment, rejecting any that do not meet the strict packaging criteria. With individual bars now fully wrapped, the next step is bundling them into larger packs. Depending on the intended retail format, Hershey's chocolate bars may be packaged as single units, multi-packs, or larger bulk boxes for wholesale distribution. Robotic arms carefully arrange the wrapped bars into predetermined configurations, stacking them into cardboard trays or shrink-wrapped bundles. For multi-packs, additional layers of protective film are applied to keep the bars securely together, preventing shifting during transportation. As the packaged chocolate bars move down the production line, they are assigned a unique batch code and expiration date, which are printed onto each wrapper using high-speed inkjet printers. This information is essential for inventory tracking, ensuring that products are rotated properly in warehouses and retail stores. It also allows Hershey's quality control team to trace any potential issues back to a specific production batch if necessary. Once all packaging steps are complete, the finished Hershey's chocolate bars are sent through final inspection before being prepared for shipment. Automated weight sensors check each package to ensure that no product is missing or underweight. Any deviations from the standard weight result in the package being removed from the line for manual inspection. After passing this final quality check, the bars are packed into large shipping cartons, which are sealed and labeled for distribution. The shipping process is a carefully orchestrated operation designed to maintain the integrity of the chocolate during transit. Hershey's distribution centers are equipped with climate-controlled storage areas, ensuring that chocolate is kept at an optimal temperature before being shipped to retailers worldwide. The pallets of chocolate bars are loaded onto refrigerated trucks, which maintain a consistent temperature to prevent melting or fat bloom. During summer months or in regions with particularly hot climates, additional measures are taken, such as using insulated packaging to further protect the chocolate from heat exposure. From the distribution centers, Hershey's chocolate bars are shipped to grocery stores, convenience stores, vending machines, and online retailers. The entire process, from sourcing cocoa beans to the moment a consumer unwraps a bar, is the result of years of expertise, precise engineering, and a deep commitment to quality. Hershey's has spent over a century refining its production methods, leveraging cutting-edge technology while preserving the craftsmanship that has made its chocolate a household favorite. Even after reaching store shelves, Hershey's continues to monitor product freshness through a network of distributors and retail partners. Inventory rotation practices ensure that consumers always receive the freshest possible product, with older stock being sold before newer shipments are placed on shelves. The brand's commitment to quality extends beyond just manufacturing. It includes every aspect of the supply chain, from sourcing raw ingredients to delivering the final product into the hands of consumers. As the packaged chocolate bars leave the production line, they move through an automated sorting system that directs them to the correct pallets for shipment. Robotic arms, programmed with artificial intelligence and real-time scanning capabilities, ensure that each batch is assigned to the right destination. Whether the chocolate bars are heading to domestic supermarkets, international retailers, or specialized distributors, each shipment is meticulously tracked using barcode scanning and digital inventory management systems. Hershey's has invested heavily in supply chain optimization, integrating real-time data analytics to monitor product flow, track expiration dates, and prevent overstocking or shortages. The process of transporting chocolate requires specific environmental controls. Hershey's distribution centers are equipped with temperature-controlled storage facilities to prevent the chocolate from being exposed to excessive heat or humidity. If chocolate bars are stored in less than ideal conditions, the risk of bloom increases. Fat bloom, the most common issue, occurs when the cocoa butter in the chocolate migrates to the surface, creating a dull, whitish coating. Sugar bloom, on the other hand, happens when moisture causes sugar crystals to form on the surface of the chocolate, resulting in a rough texture. While neither of these phenomena makes the chocolate unsafe to eat, they can negatively impact consumer perception and overall product quality. To prevent these issues, Hershey's carefully maintained storage temperatures between 65 degrees Fahrenheit and 70 degrees Fahrenheit, ensuring that the chocolate remains in optimal condition before it reaches retailers. Once the chocolate bars are loaded onto trucks, their journey continues. Hershey's logistics team coordinates shipments using a combination of ground transportation, air freight, and sea freight, depending on the destination. Domestic shipments typically travel via temperature-controlled trucks, while international shipments require specialized shipping containers equipped with insulation and climate control technology. Each step of transportation is monitored to ensure that the chocolate remains in a stable environment, preventing any degradation in quality. At retail distribution centers, Hershey's chocolate bars are unloaded and sorted based on regional demand. Large grocery chains and supermarkets often have automated warehouse systems that use conveyor belts and robotic picking technology to distribute inventory efficiently. Hershey's works closely with retailers to ensure that the product is stocked properly, preventing situations where chocolate sits in storage too long before being placed on shelves. This level of coordination ensures that customers receive the freshest possible product. Inside stores, Hershey's chocolate bars are positioned strategically to maximize sales. The company's marketing and sales teams work with retailers to determine optimal placement, typically near checkout aisles, in candy sections, and in promotional display stands designed to attract impulse buyers. Hershey's has spent years researching consumer behavior, using data-driven insights to refine its approach to in-store merchandising. Seasonal variations such as Halloween, Christmas, and Valentine's Day bring about limited edition packaging and themed chocolate products that are prominently displayed to boost sales during peak shopping periods. While the chocolate bars are now readily available for purchase, Hershey's commitment to quality control does not stop at the point of sale. The company maintains a rigorous consumer feedback system, allowing customers to report any quality concerns or irregularities. If a batch of chocolate bars is found to have any defects, Hershey's can trace the issue back to a specific production lot using the batch codes printed on each wrapper. This traceability ensures that any necessary corrective actions, such as recalls or reformulation, can be implemented quickly and efficiently. Hershey's also invests heavily in food safety measures, adhering to strict regulatory standards set by organizations such as the US Food and Drug Administration, FDA, the Food Safety Modernization Act, FSMA, and global food safety initiatives. In addition to routine quality checks throughout production, the company conducts random sampling of finished chocolate bars to test for microbial contamination, ingredient consistency, and adherence to allergen labeling guidelines. Every aspect of production, from ingredient sourcing to final packaging, is governed by good manufacturing practices, GMP, to ensure consumer safety. Beyond the standard Hershey's milk chocolate bar, the company's factories are also responsible for producing a variety of chocolate products that follow similar manufacturing principles, but may involve additional steps. For example, Hershey's with almonds requires an extra stage where roasted almonds are added to the chocolate mixture before molding. Similarly, cookies and cream variations include white chocolate blended with crunchy cocoa cookie pieces, requiring specialized mixing equipment to distribute the inclusions evenly throughout the bar. These variations highlight the flexibility of Hershey's production facilities, which are designed to accommodate multiple product lines while maintaining consistent quality. Sustainability has become an increasing focus for Hershey's in recent years. The company has taken significant steps toward reducing its environmental impact, particularly in cocoa sourcing and packaging waste reduction. Through its Cocoa for Good initiative, Hershey's invests in sustainable cocoa farming practices, providing training and financial support to farmers in West Africa and Latin America. These efforts not only help improve cocoa yields, but also ensure ethical labor practices and environmental conservation. Additionally, Hershey's has committed to using more recyclable packaging materials, reducing plastic waste in its supply chain, and lowering its carbon footprint through energy-efficient manufacturing practices. Innovation continues to drive the future of Hershey's chocolate bars. The company's research and development teams are constantly exploring new formulations, textures, and flavors to keep up with changing consumer preferences. Whether it's introducing sugar-free or plant-based chocolate alternatives, experimenting with new ingredients, or enhancing the nutritional profile of its products, Hershey's remains at the forefront of confectionery innovation. The brand has also embraced digital marketing and e-commerce, expanding its presence in online grocery platforms, direct-to-consumer sales, and subscription-based chocolate delivery services. Despite all the advancements in production technology and distribution, the core experience of enjoying a Hershey's chocolate bar remains unchanged. The familiar taste, creamy texture, and satisfying snap of the chocolate have made it a beloved treat for generations. Each bar carries with it the legacy of Milton Hershey's original vision, a high-quality chocolate product that is both accessible and affordable to consumers around the world. Looking ahead, Hershey's will continue to evolve, adapting to new market demands while staying true to the craftsmanship and quality that have defined the brand for over a century. As technology progresses, automation and artificial intelligence will play an even greater role in optimizing production efficiency, ensuring that every Hershey's chocolate bar maintains the same level of consistency and excellence. The commitment to quality, sustainability, and innovation will continue to shape the future of Hershey's chocolate, ensuring that it remains a staple in households for generations to come. The Hershey's chocolate bar, a product that has been enjoyed for over a century, is the result of a complex and highly controlled manufacturing process that blends tradition with cutting-edge technology. While the chocolate has already gone through its journey from raw cocoa beans to finished bars, wrapped and ready for sale, the process does not end there. The company continues to ensure product integrity even after distribution, keeping an eye on market trends, customer satisfaction, and ongoing improvements in production methods. Once the chocolate bars reach stores, Hershey's relies on a vast retail network to keep the product readily available for consumers. Supermarkets, convenience stores, vending machines, and online retailers all play a role in ensuring that Hershey's chocolate bars are accessible in virtually every corner of the market. In addition to traditional sales channels, Hershey's has expanded into direct-to-consumer models, offering limited edition flavors and exclusive packaging through its website and specialty stores. This move allows consumers to order their favorite Hershey's products from the comfort of their homes, ensuring freshness and convenience. Marketing plays a crucial role in maintaining Hershey's dominance in the chocolate industry. The brand has built an emotional connection with consumers, often associating its chocolate bars with childhood nostalgia, holidays, and shared moments. Advertising campaigns, social media promotions, and in-store displays reinforce the brand's image, keeping it relevant across generations. Hershey's also engages in sponsorships and collaborations, partnering with other food companies to create innovative products such as Hershey's infused baked goods, cereals, and ice cream flavors. Quality control remains a top priority even after the bars leave the factory. Hershey's has consumer feedback channels where customers can report any issues, such as damaged packaging or quality inconsistencies. The company takes such feedback seriously, using it to refine manufacturing processes and enhance overall product quality. If a defect is traced back to a specific batch, Hershey's can quickly analyze production data to determine the cause and prevent future occurrences. This level of traceability is made possible by sophisticated tracking systems that log every step of the manufacturing and distribution process. Sustainability continues to be an integral part of Hershey's long-term vision. The company is committed to ethical cocoa sourcing, reducing carbon emissions, and minimizing waste in its production facilities. Efforts include switching to more eco-friendly packaging materials, optimizing energy use in factories, and investing in cocoa farming communities to improve agricultural sustainability. By implementing these initiatives, Hershey's aims to balance business growth with environmental responsibility, ensuring that future generations can continue to enjoy its chocolate without negatively impacting the planet. Innovation is also a driving force behind Hershey's success. The company constantly experiments with new flavors, textures, and formulations, responding to emerging consumer trends such as sugar-free, high-protein, and plant-based alternatives. Research and development teams work on improving not only the taste, but also the nutritional profile of chocolate, making it more appealing to health-conscious consumers. Additionally, Hershey's has explored advancements in manufacturing efficiency, incorporating AI-driven quality checks, automation in packaging, and precision temperature control systems to maintain the highest standards in chocolate production. Despite all these advancements, the core experience of enjoying a Hershey's chocolate bar remains timeless. The simple act of unwrapping a bar, breaking off a square, and savoring the smooth, creamy texture is a universal pleasure that spans generations. Hershey's success lies in its ability to evolve while staying true to its heritage, ensuring that the chocolate remains as beloved today as it was when Milton Hershey first introduced it. Looking forward, Hershey's will continue to adapt to changing market dynamics while upholding the traditions that have defined its chocolate for over a century. Whether through expanding into new markets, refining sustainability practices, or leveraging technological innovations, the brand remains committed to delivering the same high-quality chocolate experience that consumers know and love. From the cocoa farms where it all begins to the final moment when a Hershey's chocolate bar is enjoyed, every step in the process is a testament to dedication, precision, and the enduring appeal of one of the world's most iconic chocolate brands. Producing the world's most beloved chocolate bars isn't just about great ingredients, it's a precision-driven process on an unbelievable scale. Every day, millions of Cadbury dairy milk bars are crafted inside state-of-the-art factories, where advanced machinery and carefully refined techniques transform raw cocoa into the smooth, creamy chocolate people love. The creation of a Cadbury dairy milk bar begins long before the chocolate reaches the factory. It starts on cacao farms located in tropical regions near the equator, where the conditions are ideal for growing cacao trees. The trees require warm temperatures, high humidity, and consistent rainfall to produce the cacao pods that contain the beans essential for making chocolate. These pods grow directly from the branches and trunk of the tree, taking around 6 months to mature. Farmers carefully monitor the pods, waiting until they turn from green to yellow, orange, or deep red, indicating ripeness. Harvesting is a meticulous process, as improper handling can damage the delicate cacao tree. Skilled workers use sharp machetes to cut the ripe pods from the tree, ensuring that the branch is left intact so that future pods can develop. Once harvested, the cacao pods must be processed immediately to prevent spoilage. The first step involves cracking open the thick, leathery shells to reveal the beans inside, which are surrounded by a sweet, sticky pulp. Farmers often use wooden clubs or knives to split the pods, being careful not to damage the beans within. Each pod contains around 30 to 50 beans, and thousands of these are needed to produce a single chocolate bar. The extracted beans and pulp are then placed into large wooden fermentation boxes, which are arranged in stacks to allow for air circulation. Fermentation is a crucial step in the chocolate making process, as it develops the complex flavors that will later be enhanced during roasting. The beans are left to ferment for 5 to 8 days, during which time they undergo chemical changes that transform their taste. The natural yeasts in the pulp break down the sugars, generating heat and causing the temperature inside the fermentation boxes to rise. This heat triggers biochemical reactions within the beans, breaking down their natural bitterness and releasing the precursor compounds that will later give chocolate its distinctive aroma and flavor. To ensure even fermentation, workers turn the beans periodically, usually once a day. This helps to distribute heat and oxygen throughout the pile while allowing excess moisture to evaporate. During this time, the beans gradually darken in color and develop a rich, earthy aroma. Without proper fermentation, the beans would retain a raw, astringent taste, resulting in low-quality chocolate. After fermentation is complete, the beans must be dried to reduce their moisture content and prepare them for transport. Traditionally, drying is done by spreading the beans out on large wooden trays or concrete surfaces under the sun. The drying process can take anywhere from 5 to 7 days, depending on the weather conditions. Workers frequently rake the beans to ensure they dry evenly and prevent mold growth. If the climate is too humid or rainy, mechanical dryers may be used to speed up the process and maintain quality standards. Once fully dried, the cacao beans are carefully sorted to remove any defective or damaged ones before being packed into jute sacks for shipment. These sacks are transported from cacao-producing countries to chocolate manufacturing facilities worldwide, including those used by Cadbury. Upon arrival at the factory, the first step in the production process is cleaning. The beans are loaded onto conveyor belts and passed through a series of cleaning machines that remove dirt, dust, and any remaining plant material. This ensures that only the highest quality beans proceed to the next stage. After cleaning, the beans are roasted to further develop their flavor. The roasting process is highly controlled, with temperatures and durations carefully calibrated to achieve the desired taste profile. The exact roasting conditions vary depending on the type of chocolate being produced, but for Cadbury Dairy Milk, the beans are typically roasted at temperatures between 120 to 150 degrees Celsius for about 30 to 45 minutes. During roasting, the beans undergo the Maillard reaction, a chemical process that enhances their flavor and aroma by breaking down proteins and sugars. The heat also causes the thin outer shells of the beans to become brittle, making them easier to remove in the next step. Once roasting is complete, the beans are cooled and sent through a machine called a winnower. This machine cracks the beans open, separating the outer shells from the inner nibs. The shells are removed using powerful air jets, leaving behind the pure cacao nibs, which contain the essential cocoa solids and cocoa butter needed for chocolate production. The nibs are then ground into a thick, liquid paste known as cocoa mass or cocoa liquor. This process is done using industrial grinding machines that apply high pressure to break down the nibs into tiny particles. The resulting cocoa mass has a rich, intense chocolate flavor, but is still quite coarse in texture. At this stage, the cocoa mass can be further processed to extract cocoa butter, a key ingredient in chocolate making. The mass is placed into hydraulic presses, which apply immense pressure to separate the fat, cocoa butter, from the solid components, cocoa solids. The extracted cocoa butter is a pale yellow, creamy substance that gives chocolate its smooth and creamy mouthfeel. Meanwhile, the remaining cocoa solids are ground into a fine powder, which can be used for making cocoa powder or reintroduced into the chocolate mixture for added richness. For Cadbury Dairy Milk, the next crucial step is blending the cocoa mass with other key ingredients, sugar and milk powder. Unlike dark chocolate, which relies on cocoa solids as the primary component, dairy milk chocolate has a significant proportion of milk, giving it a distinctively creamy texture and flavor. Cadbury uses fresh milk in its production process rather than relying solely on milk powder, a method that differentiates its chocolate from many other brands. The fresh milk is collected from dairy farms and transported in refrigerated tankers to the factory, where it undergoes quality control checks to ensure purity and freshness. Upon arrival, the milk is pasteurized to eliminate harmful bacteria and then concentrated to reduce its water content. This is achieved through a process called vacuum evaporation, in which the milk is heated under reduced pressure to remove excess moisture while preserving its natural flavor. The concentrated milk is then mixed with sugar to form a sweetened milk mixture, which is later blended with the cocoa mass. This unique approach, known as the crumb process, involves heating the milk and sugar together before adding them to the chocolate mixture. This technique enhances the caramelized notes of the chocolate and contributes to Cadbury's signature flavor. Once the cocoa mass, milk, and sugar are combined, the mixture undergoes refining to achieve a smooth consistency. Industrial refining machines use heavy rollers to grind the chocolate mixture, reducing the particle size to an ultra-fine level. This step is essential for creating the smooth, velvety texture that defines Cadbury Dairy Milk. If the particles are too large, the chocolate will have a grainy, rough mouthfeel, so precision in refining is crucial. The refined chocolate mixture, now resembling a dry, powdery substance, is ready for the next stage, conching. Conching is a continuous mixing and aeration process that further develops the chocolate's flavor and texture. The mixture is placed into large conching machines, where it is continuously stirred and heated for several hours. The duration of conching varies depending on the desired final texture and flavor, but for Cadbury Dairy Milk, it typically lasts between 4 to 6 hours. During this process, the chocolate's acidity and bitterness are reduced, while the smoothness and richness are enhanced. The heat and friction generated during conching also help to distribute the cocoa butter evenly, ensuring that the chocolate has a uniform texture. Once the conching process has refined the chocolate mixture into a smooth and well-developed liquid, it must undergo a crucial process known as tempering. Tempering is an essential step in chocolate production that ensures the final chocolate bars have a glossy finish, a firm structure, and the characteristic snap when broken. This process involves carefully controlling the temperature of the chocolate to stabilize the cocoa butter crystals. Cocoa butter exists in multiple crystalline forms, but only one of them, the beta crystal structure, provides the ideal texture and appearance for chocolate bars. If the chocolate is not tempered correctly, it can develop an unattractive, dull, or streaky surface and a grainy texture. Tempering is achieved through a series of precise temperature adjustments. First, the liquid chocolate is gradually cooled to around 27 to 28 degrees Celsius, which encourages the formation of stable beta crystals. Then, the temperature is raised slightly to about 31 to 32 degrees Celsius for milk chocolate, melting any unwanted crystal structures while keeping the stable ones intact. This ensures that when the chocolate cools and solidifies in the molds, it will have a smooth and uniform consistency. Large-scale chocolate tempering machines, which are fully automated, are used in Cadbury's factories to maintain this process with extreme precision. These machines continuously agitate the chocolate while controlling its temperature at various stages, ensuring that the cocoa butter crystallizes correctly. Once tempering is complete, the chocolate is ready for molding. The tempered chocolate is transferred to an automated molding system where it is poured into specially designed molds that give Cadbury dairy milk bars their iconic shape and thickness. The molds are made of food-grade polycarbonate plastic or stainless steel and are designed to create perfectly uniform chocolate bars. The molding system ensures that each bar receives the precise amount of liquid chocolate needed for consistent weight and shape. To ensure that the chocolate fills every crevice of the mold and eliminates any trapped air bubbles, the molds pass through a vibrating station. This high-frequency vibration gently shakes the molds, allowing the liquid chocolate to settle evenly and remove any unwanted air pockets. This step is crucial in creating a uniform texture throughout the bar, as any trapped air can lead to weak spots or inconsistencies in the final product. Once the chocolate is evenly distributed in the molds, the bars must be cooled to solidify completely. The molds move along a conveyor belt into a cooling tunnel, a temperature-controlled environment that gradually reduces the temperature of the chocolate. Cooling must be done gradually to prevent the formation of sugar or fat bloom, which can create a white or grayish appearance on the surface of the chocolate. The cooling tunnels are typically set at temperatures between 5 to 10 degrees Celsius, and the bars spend around 20-30 minutes inside, depending on their thickness and size. During this time, the chocolate transitions from a liquid state to a solid form with a firm structure and smooth texture. After cooling, the solidified chocolate bars are carefully removed from the molds using an automated demolding system. This process is designed to be gentle to prevent breakage, ensuring that each bar maintains its perfect shape. The bars are then sent along conveyor belts for the next stage, quality inspection. At this point, every chocolate bar undergoes a thorough quality control check to ensure it meets Cadbury's strict standards. High-speed cameras and laser sensors scan the chocolate bars for any imperfections, such as cracks, air bubbles, or irregular shapes. Bars that do not meet quality standards are removed from the production line and either reprocessed or discarded. Factory workers also conduct random manual inspections, checking for surface smoothness, uniform thickness, and the signature Cadbury dairy milk texture. Once the bars have passed the quality inspection stage, they move on to the packaging process. Packaging is an essential part of chocolate production, as it protects the chocolate from external factors such as moisture, air, and temperature changes that could affect its quality. The packaging process begins with automated machines wrapping each chocolate bar in a protective layer. Traditionally, Cadbury dairy milk bars were wrapped in foil with a paper sleeve, but modern packaging now consists of a specially designed plastic film that provides better sealing and protection. The packaging machines work at incredibly high speeds, wrapping hundreds of chocolate bars per minute. Each bar is precisely aligned and fed into the packaging machine, where the plastic film is cut and wrapped tightly around it. Heat sealing technology ensures that the package is securely sealed, keeping the chocolate fresh and protected from environmental factors. Once wrapped, the bars are sent through a labeling station, where product information such as batch numbers, expiration dates, and barcodes are printed onto the packaging. After labeling, the individually wrapped chocolate bars are grouped together into larger multi-packs or cartons, depending on the intended retail format. These multi-packs are then placed into shipping boxes, which are sealed and prepared for distribution. To ensure efficiency in the supply chain, Cadbury's factory uses automated robotic systems to stack the finished boxes onto pallets. These robotic arms work with incredible precision, organizing the boxes in a way that maximizes space while ensuring stability during transport. The pallets of Cadbury dairy milk bars are then transferred to the factory's storage and distribution center, where they are kept in temperature-controlled warehouses before being shipped to retailers worldwide. The storage conditions are carefully maintained to prevent temperature fluctuations, as chocolate is highly sensitive to heat and humidity. Ideal storage temperatures for chocolate typically range between 15 to 18 degrees Celsius to prevent melting, fat bloom, or sugar crystallization. Once ready for distribution, the chocolate bars are loaded onto refrigerated trucks and transported to supermarkets, convenience stores, and other retail outlets. Cadbury ensures that strict logistics and transportation protocols are followed to maintain the quality of the chocolate during transit. These trucks are equipped with temperature-controlled systems that prevent overheating or exposure to extreme temperatures, ensuring that the chocolate arrives in perfect condition. Upon arrival at retail locations, the chocolate bars are displayed on store shelves, ready for consumers to purchase. The iconic purple packaging and recognizable branding make Cadbury Dairy Milk one of the most easily identifiable chocolate products on the market. From the initial stages of cacao cultivation to the moment a customer unwraps a bar, every step in the production process is meticulously designed to deliver the perfect balance of smoothness, creaminess, and rich chocolate flavor that has made Cadbury Dairy Milk a favorite for generations. The next stage in the manufacturing process is focused on large-scale efficiency, ensuring that every single Cadbury Dairy Milk bar produced maintains the same level of quality, texture, and taste. Once the bars are molded, cooled, and packaged, the production line moves seamlessly into the next critical phase: quality control and inspection. While some initial checks were already performed during molding and packaging, this stage is dedicated to an in-depth analysis of every batch to guarantee consistency. Cadbury employs an extensive quality control system using a combination of automated technology and human oversight. High-speed cameras and infrared scanners are positioned along the conveyor belts to detect any visible imperfections, such as cracks, surface defects, or uneven molding. These sophisticated imaging systems compare each chocolate bar against a pre-programmed reference model, instantly flagging any inconsistencies. Defective bars are automatically removed from the production line and sent to a separate area where they may be either reprocessed or discarded depending on the severity of the defect. Beyond the physical appearance of the bars, texture and taste are also key factors that must be evaluated. Every production batch undergoes sample testing, where factory workers manually inspect a random selection of bars, breaking them to listen for the characteristic snap that signifies proper tempering. The texture is also analyzed using precision measuring instruments that evaluate the chocolate's density and uniformity. To maintain Cadbury's signature creamy mouthfeel, particle size analysis is conducted to ensure that the chocolate's refined mixture maintains a smooth consistency. If any deviations are detected, the production settings are adjusted in real time to correct potential issues before they impact the entire batch. In addition to visual and textural inspections, extensive taste testing is performed. Cadbury employs trained sensory panels, experts with highly developed palates, to sample and evaluate each batch of dairy milk chocolate. These professionals assess the chocolate for its signature balance of sweetness, creaminess, and cocoa richness. The sensory panelists follow a structured evaluation process, examining attributes such as melt rate, lingering aftertaste, and flavor complexity. To ensure objective results, the tasters follow strict guidelines, such as cleansing their palates between samples and tasting in a controlled environment, free from external odors or distractions. Once the quality control stage is successfully completed, the chocolate bars proceed to the final stage of distribution. At this point, thousands of bars are packed into cartons and prepared for shipment. The logistics of distributing Cadbury Dairy Milk bars to retailers worldwide is a highly coordinated effort. Each carton is scanned, labeled, and sorted based on its destination. Advanced inventory management systems track every unit in real time, ensuring that supply chain operations remain smooth and efficient. Temperature-controlled storage is an essential part of this process. Since chocolate is highly sensitive to temperature and humidity, Cadbury warehouses maintain precise environmental conditions. Storage temperatures are carefully kept within the optimal range of 15 to 18 degrees Celsius to prevent issues such as fat bloom, a white discoloration caused by fat migration, or sugar bloom, a grainy surface texture caused by moisture exposure. To further protect the chocolate, humidity levels in the warehouse are monitored to prevent condensation from forming inside the packaging. Once the chocolate bars are ready for transport, they are loaded onto specially designed delivery trucks equipped with temperature regulation systems. These vehicles are programmed to maintain ideal conditions throughout transit, ensuring that the chocolate does not melt or suffer quality degradation. The bars are then transported to distribution centers, where they are sorted and prepared for delivery to supermarkets, convenience stores, and online retailers. The final stage of the Cadbury Dairy Milk Bar's journey, from its creation in the factory to reaching the hands of consumers, is a combination of advanced logistics, careful storage, and precise distribution. Ensuring that millions of chocolate bars arrive in perfect condition across the globe requires an intricate supply chain. Every Cadbury Dairy Milk bar, once fully manufactured, undergoes a detailed process of warehousing, transportation, retail placement, and eventual purchase by consumers. After passing rigorous quality control checks, the packaged chocolate bars are sent to Cadbury's automated warehousing facilities. These warehouses are designed with climate control systems that maintain optimal conditions for chocolate storage. Chocolate is highly sensitive to temperature fluctuations and humidity, which can lead to fat bloom or sugar bloom if not stored correctly. Fat bloom appears as a whitish discoloration on the chocolate surface, caused by unstable cocoa butter rising to the surface when exposed to inconsistent temperatures. Sugar bloom, on the other hand, results from moisture interacting with sugar particles, causing a rough and grainy texture. To prevent these defects, Cadbury's warehouses maintain a consistent temperature range of 15 to 18 degrees Celsius and humidity levels below 50%. Within the warehouse, an automated storage and retrieval system organizes and categorizes the chocolate bars based on their batch numbers and expiration dates. These systems use robotic arms and conveyor systems to efficiently stack and move cartons of dairy milk bars without human intervention, ensuring minimal handling and reducing the risk of damage. Advanced barcode and RFID scanning technology is employed to track every individual batch, allowing real-time monitoring of inventory levels. This ensures that products are shipped in the correct order, prioritizing freshness and reducing waste. Once ready for distribution, the Cadbury Dairy Milk bars are loaded onto transport trucks for delivery. The logistics of transporting chocolate require carefully planned routes and specially equipped vehicles to prevent exposure to extreme temperatures. In warmer climates, refrigerated trucks are used to maintain the optimal temperature during transport. These trucks are fitted with sensors that continuously monitor temperature conditions, ensuring that any fluctuations can be corrected before they affect the product's quality. From the warehouse, the chocolate bars are delivered to national and international distribution centers. These hubs play a crucial role in breaking down large shipments into smaller deliveries destined for specific retailers. Here, logistics teams coordinate the efficient redistribution of the products to supermarkets, convenience stores, online retailers, and vending machine suppliers. The entire process is optimized using software systems that calculate the most efficient routes and delivery schedules, reducing transit time and ensuring the freshest product reaches store shelves as quickly as possible. Upon arriving at retail locations, Cadbury Dairy Milk bars are placed in designated areas based on carefully planned merchandising strategies. Retailers follow specific guidelines to position the chocolate bars in high-traffic areas, maximizing visibility and impulse purchases. Supermarkets often stock dairy milk bars in checkout aisles, where customers are more likely to grab a bar as a last-minute addition to their purchases. Convenience stores and gas stations also follow similar placement strategies, ensuring that dairy milk bars are easily accessible and prominently displayed. Beyond traditional retail spaces, online shopping has become an increasingly important channel for Cadbury Dairy Milk sales. E-commerce platforms allow consumers to order chocolate bars directly from Cadbury or through third-party retailers. These online orders are fulfilled from dedicated warehouses where products are carefully packed to prevent breakage during shipping. Insulated packaging may be used in regions with hot climates to ensure that the chocolate remains solid during transit. Subscription services and bulk purchasing options also contribute to the growing presence of dairy milk in the online marketplace. Once the chocolate bar reaches the hands of the consumer, the experience of enjoying Cadbury Dairy Milk is the culmination of a long and carefully controlled process. The signature smooth texture and rich taste of the chocolate are as a result of every meticulous step taken throughout the journey, from the cacao farms to the final packaging. The unique flavor of dairy milk is achieved through the combination of high-quality cocoa beans, fresh milk, and precisely controlled manufacturing techniques. In addition to producing high-quality chocolate, Cadbury is also committed to sustainability and ethical sourcing. The company's partnership with the Cocoa Life program ensures that the cocoa used in dairy milk bars is sourced responsibly. This initiative works directly with cocoa farmers to improve farming practices, provide fair wages, and promote environmental conservation. By investing in sustainable cocoa production, Cadbury helps to support the livelihoods of farmers while ensuring a stable and high-quality supply of cocoa for the future. Similarly, Cadbury has made strides in reducing its environmental footprint in manufacturing and packaging. The company is working towards more sustainable packaging solutions, aiming to reduce plastic waste and increase recyclability. Innovations such as thinner plastic film, recyclable paper-based wrappers, and biodegradable packaging materials are being developed to align with global sustainability goals. In the manufacturing process, energy-efficient machinery and waste reduction programs contribute to minimizing the factory's carbon footprint. The process begins with the careful selection and sourcing of raw ingredients. The primary components of KitKat bars include wheat flour, sugar, cocoa mass, cocoa butter, milk powder, vegetable oils, and emulsifiers. Nestlé, the brand behind KitKat, sources these ingredients from various regions worldwide, ensuring sustainability and adherence to strict quality standards. The cocoa used in KitKat is primarily sourced from the Nestlé Cocoa Plan, which promotes sustainable farming practices and fair trade. Once the raw materials arrive at the production facility, they undergo a series of inspections and tests to verify purity, consistency, and compliance with food safety regulations. This includes spectroscopic analysis for contaminants, moisture content testing, and sensory evaluations conducted by trained professionals. Once approved, the ingredients are stored in temperature-controlled silos and dispensing systems. The flour is kept in airtight storage to prevent contamination, while cocoa and milk powder are maintained under controlled humidity conditions to prevent clumping. Automated feeding systems transport these raw materials to the respective processing units, ensuring precise measurement and consistency in formulation. The first major step in KitKat production is wafer baking. The signature light and crispy wafer layers are created through a precise blending of wheat flour, water, sugar, and vegetable oils. Large industrial mixers, equipped with programmable logic controllers, ensure thorough mixing to produce a smooth and homogeneous batter. Once mixed, the batter is transferred via pressurized pumps to high-speed continuous wafer baking ovens. These ovens feature rotating baking plates that evenly distribute the batter across the surface, forming thin sheets of wafer. The baking plates operate at carefully controlled temperatures, typically around 180 to 200 degrees Celsius, ensuring uniform texture and color. The baked wafer sheets emerge golden brown and crisp, ready for the next stage. To enhance the crispness, the wafer sheets pass through a controlled cooling system. Conveyor belts transport the freshly baked wafers through a cooling tunnel, where calibrated fans gradually reduce the temperature to prevent thermal shock. The cooled wafers are then directed to the trimming and cutting station. Automated guillotine cutters trim the edges of the wafers to achieve uniform dimensions, ensuring consistency across all KitKat bars. Once trimmed, the wafers are transported to the layering station. Here, a fine layer of chocolate cream filling made from a precise blend of cocoa, sugar, and milk powder is evenly spread onto the wafers. Automated depositor machines ensure the filling is applied uniformly, maintaining the right thickness for optimal texture. The layering process continues with additional wafer sheets stacked on top, creating a multi-layered wafer slab. These slabs are then pressed under controlled pressure to bond the layers together without crushing the delicate structure. After layering, the wafer slabs proceed to the cutting stage. High-speed rotary or ultrasonic blade systems slice the large wafer sheets into precise rectangular portions, forming the individual KitKat fingers. Ultrasonic cutting technology is particularly effective in ensuring clean, precise cuts without generating excess crumbs or damaging the layers. The next crucial step is chocolate enrobing. The enrobing process begins with the preparation of molten milk chocolate, which is produced in large conching machines. These machines continuously grind and blend cocoa mass, cocoa butter, sugar, and milk powder, refining the mixture to achieve a smooth, velvety consistency. The conching process, which can last several hours, helps develop the rich, creamy texture and enhances the flavor profile of the chocolate. Once ready, the molten chocolate is fed into enrobing machines, where KitKat fingers pass through a curtain-like flow of chocolate. These enrobers ensure complete coverage, with excess chocolate removed using controlled air jets and vibrating conveyors. To achieve the signature glossy finish, the enrobed bars pass through a tempering unit, which carefully regulates the chocolate's crystallization process. This involves a precise cycle of heating, cooling, and reheating to stabilize the cocoa butter crystals, preventing bloom and ensuring a smooth, even texture. Following enrobing, the chocolate-covered KitKat bars enter a cooling tunnel. This tunnel, equipped with multi-zoned cooling technology, gradually reduces the temperature in stages to solidify the chocolate coating without causing cracks or condensation. The cooling process is carefully monitored using infrared sensors to maintain consistency. Once the chocolate is fully set, the KitKat bars move to the quality control and inspection stations. Advanced vision inspection systems, equipped with high-resolution cameras, scan each bar for defects, such as uneven coating, improper sizing, or misaligned layers. Bars that do not meet quality standards are automatically rejected by robotic sorting arms and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. After passing inspection, the KitKat bars are transported to high-speed wrapping machines. Individual bars are wrapped in foil or plastic film using heat sealing technology, ensuring airtight packaging that preserves freshness. These wrapped bars are then grouped into multi-packs, which are subsequently boxed using robotic case packers. The packaging design is carefully printed with product details, barcodes, and branding elements before final sealing. The packaged KitKat bars are then palletized for distribution. Automated palletizing systems stack the boxes onto pallets in a precise arrangement to optimize space utilization during transportation. These pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for delivery to distribution centers worldwide. The logistics process is carefully coordinated to ensure timely delivery, with real-time tracking systems monitoring shipments from factory to retailer. Throughout the entire production process, extensive quality control measures are in place to uphold product integrity. Each batch undergoes rigorous laboratory testing, including microbiological screening, allergen testing, and texture analysis. Data from all processing stages is logged in automated tracking systems, allowing full traceability and compliance with food safety regulations. While the fundamental principles of KitKat production remain consistent across different manufacturing plants, regional variations may exist to cater to local tastes and preferences. For example, KitKat flavors such as matcha green tea, strawberry, and sake are produced in Japan using specialized formulations. Some factories may also incorporate alternative chocolate blends, varying cocoa content to suit market demands. Nestlé continues to innovate and optimize KitKat production through advancements in automation, sustainability initiatives, and ingredient sourcing. Modern factories are increasingly utilizing AI-driven quality control systems, energy-efficient processing equipment, and eco-friendly packaging solutions to reduce environmental impact. With continuous improvements in manufacturing technology, KitKat remains a global favorite, offering consumers a consistently delightful chocolate experience in every bite. Mars bars, one of the most iconic chocolate confections in the world, are produced in highly sophisticated manufacturing facilities designed to ensure consistency, efficiency, and quality at every step of the process. The production of Mars bars involves multiple intricate stages, from sourcing and processing raw ingredients to forming, enrobing, cooling, and packaging the final product. Each step is meticulously controlled using advanced automation technology and stringent quality control measures to ensure the signature caramel, nougat, and chocolate combination is perfectly replicated in every bar. The process begins with the careful selection of raw ingredients. The main components of a Mars bar include sugar, cocoa mass, cocoa butter, skimmed milk powder, whey powder, palm fat, glucose syrup, lactose, milk fat, and egg whites. These ingredients are sourced from trusted suppliers and undergo rigorous quality assurance checks upon arrival at the factory. Sugar, which plays a crucial role in both the nougat and caramel layers, is stored in large silos, where it is kept dry and free from contamination. Cocoa products, including cocoa mass and cocoa butter, are stored in climate-controlled environments to prevent degradation. Dairy ingredients such as skimmed milk powder and whey powder are tested for purity and consistency before use. Once the raw ingredients are approved, the first major stage in Mars bar production is the creation of the nougat layer. Nougat is a key structural component of the bar, providing a soft, chewy texture that contrasts with the caramel and chocolate. The nougat making process begins in large industrial mixing tanks, where a combination of sugar, glucose syrup, and water is heated to create a syrup. This syrup is then aerated using a whipping system, which incorporates fine air bubbles to achieve the desired light and fluffy texture. During this stage, egg whites or hydrolyzed soy protein are added as stabilizers to maintain the nougat's consistency. Once the nougat mixture reaches the proper texture, it is transferred onto a continuous conveyor belt, where it is spread into an even layer. This belt passes through a cooling tunnel to allow the nougat to set before it reaches the next stage of the process. The cooled nougat layer is then precisely cut into rectangular strips using high-speed guillotine cutters. These strips will form the base of each Mars bar. The next step in the process is the caramel layer. The caramel used in Mars bars is created through a controlled cooking process that involves heating sugar, glucose syrup, and milk ingredients to high temperatures. This process requires careful monitoring to achieve the perfect balance of sweetness and viscosity. Industrial batch cookers equipped with automated temperature controls ensure that the caramel reaches the ideal consistency before it is deposited onto the nougat base. The caramel is applied as a continuous sheet over the nougat layer, ensuring even distribution and uniform thickness. Once the caramel is applied, the combined nougat and caramel layers proceed through a controlled cooling tunnel, where the temperature is gradually reduced to allow the caramel to set without becoming too hard or sticky. This ensures that the layers remain cohesive and easy to cut in the next stage of production. After cooling, the layered nougat and caramel sheets are fed into an automated cutting system, which uses precision blades to slice them into individual bar-sized portions. These freshly cut bars are then transported via conveyor belts to the enrobing station, where they receive their final chocolate coating. The enrobing process is a critical step in Mars bar production, as it gives the bars their signature smooth milk chocolate exterior. The chocolate coating is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder, which is carefully tempered to achieve the perfect texture and glossy finish. The tempering process involves heating and cooling the chocolate in a controlled manner to ensure the cocoa butter crystals form a stable structure, preventing fat bloom and ensuring a smooth mouthfeel. At the enrobing station, the cut nougat and caramel bars pass through a curtain-like waterfall of molten chocolate, which fully coats them. Excess chocolate is removed using controlled air jets and vibrating conveyors to ensure an even layer without excessive buildup. Some factories use a two-stage enrobing process, where an initial thin layer of chocolate is applied as a base coat before the final, thicker chocolate layer is added. After enrobing, the chocolate-covered bars enter a multi-zone cooling tunnel, which gradually reduces their temperature in controlled stages. This cooling process allows the chocolate to set properly without developing cracks or a dull surface. The bars emerge from the cooling tunnel with a perfectly set chocolate shell, ready for the final stages of quality control and packaging. Quality control is a fundamental part of Mars bar production, ensuring that only bars meeting strict standards reach consumers. Automated vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, misshapen forms, or inconsistencies in size. Bars that do not meet the required specifications are automatically rejected and sent for reprocessing. Additional quality control measures include weight checks using precision weighing systems, texture analysis, and sensory evaluations conducted by trained specialists. Once the bars pass quality inspection, they proceed to the packaging area, where high-speed wrapping machines individually wrap each bar in foil or plastic film. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and placed into branded cartons, which are sealed and labeled using automated case packing systems. The final step in the process is palletization and distribution. Automated palletizing systems stack the packaged bars onto pallets in a precise arrangement to optimize space utilization during transportation. The pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retail stores and supermarkets worldwide. The entire logistics process is carefully coordinated to ensure timely delivery while maintaining the product's freshness and quality. Throughout the entire manufacturing process, Mars maintains stringent quality control and food safety standards. Each production batch undergoes extensive laboratory testing, including microbial analysis, allergen testing, and moisture content verification. The company also invests in sustainable sourcing initiatives, ensuring that key ingredients such as cocoa and palm oil are responsibly sourced to minimize environmental impact. Different Mars manufacturing facilities may incorporate slight variations in processing techniques based on regional ingredient availability, consumer preferences, or proprietary formulations. Some facilities may use alternative chocolate blends with varying cocoa content to cater to specific markets, while others may modify the nougat formulation for textural differences. Additionally, Mars continuously invests in research and development to improve efficiency, reduce energy consumption, and enhance sustainability in its production processes. With advancements in automation, AI-driven quality control systems, and eco-friendly packaging innovations, the production of Mars bars continues to evolve while maintaining the signature taste and texture that consumers have loved for generations. Twix, one of the world's most beloved chocolate bars, is manufactured using a highly sophisticated and automated process that ensures each bar maintains its signature combination of crunchy biscuit, smooth caramel, and creamy milk chocolate coating. The production of Twix bars occurs in state-of-the-art factories that utilize precision engineering, cutting-edge food processing technology, and rigorous quality control protocols. From the sourcing of raw ingredients to packaging and distribution, every step is carefully orchestrated to guarantee consistency, efficiency, and superior taste. The process begins with the selection and procurement of high-quality raw materials. The key ingredients in Twix bars include wheat flour, sugar, palm oil, cocoa butter, skimmed milk powder, cocoa mass, lactose, whey powder, salt, and emulsifiers. These ingredients are sourced from carefully vetted suppliers who must meet strict food safety and sustainability requirements. For instance, the cocoa used in Twix bars is sourced through Mars' Cocoa for Generations initiative, ensuring ethical sourcing and environmental responsibility. Similarly, the palm oil used in the biscuits and caramel is certified sustainable to reduce environmental impact. Upon arrival at the manufacturing facility, the raw ingredients undergo thorough quality checks before entering the production process. These checks include spectroscopic analysis to detect contaminants, moisture content analysis to ensure freshness, and sensory evaluations to verify taste and aroma. Ingredients that meet the necessary standards are then stored in temperature-controlled silos and storage units to maintain their quality. The first step in the actual production process is the creation of the biscuit base. Twix bars are distinguished by their crunchy, shortbread-like biscuit layer, which requires precise preparation and baking. The process begins in large industrial mixers, where wheat flour, sugar, palm oil, and leavening agents are combined to form a dough. The mixing process is carefully timed to ensure the dough reaches the ideal consistency, firm enough to hold its shape during baking, yet tender enough to create the signature crisp texture. Once the dough is fully mixed, it is transferred to an automated sheeting system. This system rolls the dough into a uniform sheet of the exact thickness required for Twix bars. The sheeted dough then moves to a rotary cutting machine, which stamps out individual biscuit fingers. Each biscuit is precisely cut to ensure uniform size and shape, allowing for seamless assembly in later stages. The cut dough pieces are placed onto conveyor belts and transported into a large industrial baking oven. These ovens operate using a continuous baking system where the biscuit fingers travel through different heat zones that gradually bake them to perfection. The baking temperature is carefully controlled, typically ranging between 180 to 200 degrees Celsius, 356 to 392 degrees Fahrenheit, ensuring that each biscuit is evenly baked to a golden brown. Advanced infrared sensors monitor the biscuits throughout the baking process, ensuring uniformity in color, texture, and moisture content. Once fully baked, the biscuits pass through a cooling tunnel that gradually reduces their temperature, preventing cracking or breakage. Next, the caramel layer is prepared. The caramel used in Twix bars is made from a precise blend of sugar, glucose syrup, milk, and butter. This mixture is heated in large stainless steel batch cookers, where it undergoes controlled caramelization. The temperature and cooking time are crucial in achieving the perfect consistency, thick enough to stay in place on the biscuit, but soft enough to deliver a smooth, chewy texture. Once the caramel reaches the desired consistency, it is transferred to a continuous depositor system. This machine evenly dispenses a uniform layer of caramel onto each biscuit. The caramel application must be carefully controlled to ensure consistency in thickness across all bars. Any inconsistencies could lead to difficulties in chocolate enrobing or affect the final texture. With the caramel applied, the bars move along the conveyor belt to a cooling station, where they pass through a controlled cooling tunnel. This tunnel gradually reduces the temperature of the caramel, allowing it to set properly while maintaining its soft, chewy texture. After cooling, the caramel-coated biscuits are ready for the enrobing process, where they will be covered in rich milk chocolate. The enrobing process is one of the most critical steps in Twix production. The milk chocolate coating is prepared in large conching machines, which continuously grind and refine cocoa mass, cocoa butter, sugar, and milk powder. This process enhances the texture and flavor of the chocolate, ensuring a smooth, creamy consistency. The chocolate is then tempered, a controlled heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering is essential to achieving the signature glossy finish and preventing fat bloom, white streaks that can appear on improperly tempered chocolate. At the enrobing station, the caramel-topped biscuits pass through a continuous chocolate waterfall. This ensures that each bar is fully coated in an even layer of chocolate. Any excess chocolate is removed using controlled air jets and vibrating conveyors, which help distribute the chocolate evenly without excessive buildup. Some factories employ a two-stage enrobing process, where a thin base coat of chocolate is applied first to ensure better adhesion before the final, thicker chocolate layer is added. Once the bars are coated, they enter a multi-zone cooling tunnel. This tunnel is divided into different temperature zones that gradually reduce the temperature, allowing the chocolate to set perfectly without cracking or becoming dull. The bars emerge from the cooling tunnel with a firm, glossy chocolate coating, ready for the next stage of production. Quality control is a top priority at every stage of Twix production. After cooling, the bars pass through a series of automated inspection systems. High-speed vision cameras scan each bar for inconsistencies in chocolate coating, caramel distribution, and overall shape. Any bars that do not meet specifications are automatically rejected and sent for reprocessing. In addition to visual inspections, quality control teams conduct random weight checks, moisture analysis, and sensory evaluations to ensure that each batch meets Mars's stringent quality standards. Once the bars have passed inspection, they move to the packaging stage. Twix bars are individually wrapped using high-speed horizontal flow wrapping machines. These machines use heat-sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs, which are sealed in branded cartons using automated case packing systems. After packaging, the final step in the process is palletization and distribution. Robotic palletizing systems stack the packaged bars onto pallets in precise arrangements, optimizing space for transport. The pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Mars utilizes an advanced logistics network to ensure efficient delivery while maintaining product freshness. Throughout the entire production process, Mars adheres to strict food safety and sustainability standards. Each batch undergoes rigorous laboratory testing, including microbiological analysis, allergen testing, and texture verification. The company also invests in eco-friendly initiatives, such as reducing energy consumption in manufacturing and using recyclable packaging materials. Different Mars factories may employ slight variations in processing techniques based on regional ingredient availability and consumer preferences. For example, some regions may use alternative chocolate formulations with varying cocoa content, while others may adjust the caramel consistency based on market preferences. Additionally, limited edition Twix flavors, such as Twix white chocolate and Twix peanut butter, require modifications in ingredient formulation and processing techniques. As consumer demand for innovative flavors and healthier options grows, Mars continues to invest in research and development to improve Twix production. Recent advancements in AI-driven quality control, robotic automation, and sustainable ingredient sourcing are shaping the future of Twix manufacturing. Despite these innovations, the core principles of precision, consistency, and quality remain unchanged, ensuring that every Twix bar delivers the signature, crunchy, chewy, and chocolatey experience that consumers love. The making of a Hershey's chocolate bar is a complex, highly automated process that combines tradition with cutting-edge technology. From sourcing high-quality cocoa beans to wrapping the final product, every step is optimized for efficiency, consistency, and taste. The journey of a Hershey's bar begins with the careful selection of raw ingredients sourced from around the world. Cocoa, sugar, milk, and other ingredients are carefully tested to ensure they meet the company's high standards before they are transformed into the iconic chocolate bars that have been loved for generations. At the heart of every Hershey's chocolate bar is cocoa. The company sources its cocoa beans primarily from Ghana, Côte d'Ivoire, and Ecuador, regions known for producing high-quality beans with robust flavor profiles. Cocoa farmers in these areas harvest the ripe pods, extract the cocoa beans, and allow them to ferment for several days to develop their characteristic chocolatey taste. Once dried, the beans are shipped to Hershey's production facilities, where they undergo rigorous quality checks. Each shipment is tested for moisture content, flavor consistency, and the absence of contaminants. Only the highest quality beans make it through this stringent selection process. Once approved, the cocoa beans are sent to the roasting stage. Large industrial roasters expose the beans to carefully controlled heat, typically between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit, depending on the desired flavor profile. The roasting process is essential for developing the deep, complex flavors of chocolate. Different roasting profiles are used depending on whether the beans will be used for milk chocolate, dark chocolate, or other specialty products. After roasting, the cocoa beans enter the winnowing process. Specialized machinery cracks the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both the cocoa solids and cocoa butter needed for chocolate production. The nibs are then ground into a thick, dark paste known as chocolate liquor, which contains no alcohol despite its name. This chocolate liquor is the base for all Hershey's chocolate products. For Hershey's classic milk chocolate bars, chocolate liquor is combined with sugar, milk, and cocoa butter. The milk used in Hershey's chocolate is a key ingredient that gives it its distinctive taste. Unlike many European chocolates that use powdered or condensed milk, Hershey's uses fresh milk sourced from dairy farms in Pennsylvania and surrounding states. The milk is pasteurized and condensed before being blended with sugar to create a sweet, creamy base. The next stage in the process is refining. The chocolate mixture is run through a series of steel rollers that grind the particles to an ultra-fine consistency. This refining process is crucial for creating a smooth, melt-in-your-mouth texture. The finer the particles, the smoother the final chocolate will be. Once refined, the chocolate undergoes conching, a critical process that enhances flavor and texture. Conching machines, which resemble large industrial mixers, continuously stir the chocolate at controlled temperatures for several hours. This process aerates the chocolate, allowing unwanted acidic compounds to evaporate while enhancing its creamy mouthfeel. Hershey's uses a proprietary conching method that contributes to its signature flavor, which has a slightly tangy undertone due to controlled acidity in the milk. After conching, the chocolate moves to the tempering stage. Tempering is the process of heating and cooling chocolate in a precise manner to stabilize the cocoa butter crystals. Proper tempering ensures that Hershey's bars have a glossy finish, a firm snap, and a long shelf life. If the chocolate were not tempered correctly, it could develop fat bloom, a whitish streaking effect caused by unstable cocoa butter. Now, the tempered chocolate is ready for molding. Automated machines pour precise amounts of liquid chocolate into bar-shaped molds, which are then vibrated to remove air bubbles and ensure even distribution. The molds travel along a conveyor system into a cooling tunnel, where the chocolate solidifies into its final shape. Once cooled, the bars are ejected from their molds and transported via conveyor belts to the packaging area. Here, high-speed wrapping machines encase each bar in foil and branded paper sleeves, protecting the chocolate from moisture and light while ensuring a fresh, appealing presentation. Throughout the entire process, strict quality control measures are in place. High-resolution vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or size inconsistencies. Bars that do not meet specifications are automatically rejected and sent for reprocessing. Additionally, random sensory evaluations are conducted by trained taste testers to ensure that the flavor, texture, and overall quality remain consistent. Once packaged, the final step is palletization and distribution. Automated robotic arms stack the packaged bars onto pallets, which are then shrink-wrapped for stability. These pallets are loaded onto temperature-controlled trucks and shipped to retailers worldwide. Hershey's operates an advanced logistics network that ensures timely delivery while maintaining product freshness. The entire manufacturing process is designed for efficiency, consistency, and sustainability. Hershey's continues to invest in eco-friendly initiatives, such as reducing water and energy consumption in production, using ethically sourced cocoa, and optimizing packaging materials to minimize waste. Different Hershey's factories may employ slight variations in processing techniques based on regional preferences and ingredient availability. Additionally, specialty products like Hershey's cookies and cream bars or Hershey's dark chocolate require modifications in ingredient formulation and processing times. As the chocolate industry continues to evolve, Hershey's remains at the forefront of innovation, combining tradition with advanced manufacturing techniques to produce its iconic chocolate bars. Through precision engineering, strict quality control, and a commitment to excellence, Hershey's ensures that every bar delivers the same beloved taste that generations have enjoyed. The making of Toblerone, the iconic triangular chocolate bar, is a masterclass in precision engineering, premium ingredient selection, and automated manufacturing processes. Unlike conventional chocolate bars, Toblerone stands out for its distinctive shape, rich Swiss milk chocolate, and the inclusion of honey and almond nougat. Every step, from sourcing the finest ingredients to molding the signature peaks, is meticulously controlled to ensure quality, consistency, and adherence to the Swiss chocolate making tradition. The process begins with sourcing high-quality ingredients. Toblerone's signature flavor comes from its carefully selected components: Swiss milk, sugar, cocoa mass, cocoa butter, honey, almonds, and egg whites. The milk, sourced from Swiss dairy farms, is a critical ingredient that contributes to the creamy texture. The cocoa is sourced from sustainable farms in Ghana and Ecuador, where beans are hand-harvested, fermented, and dried under strict quality control measures. Almonds are procured from select suppliers, ensuring they meet the required standards of size, flavor, and crunch. The honey, a key component that adds a subtle sweetness, is sourced from European beekeepers specializing in high-quality aromatic varieties. Once the ingredients arrive at the production facility, they undergo rigorous quality checks. Advanced spectroscopic analysis, moisture content testing, and flavor profiling ensure that each ingredient meets the brand's high standards. The cocoa beans are then roasted at carefully controlled temperatures to develop their deep, complex flavor. Different roasting profiles are used depending on whether the beans will be used for Toblerone's milk, dark, or white chocolate variations. After roasting, the cocoa beans move to the winnowing stage, where high-powered machinery cracks them open and removes the husks. The remaining cocoa nibs, which contain the essence of the chocolate, are then finely ground into a thick, rich paste known as chocolate liquor. This forms the base of Toblerone's chocolate. The chocolate liquor is blended with sugar, cocoa butter, and Swiss milk powder to create the signature, smooth and creamy chocolate mixture. The next step in the process is refining. The chocolate mixture passes through a series of heavy-duty steel rollers that break down the particles to an ultra-fine consistency. This is crucial in achieving the signature melt-in-your-mouth texture. The refining process also helps blend the ingredients evenly, ensuring a perfectly smooth mixture. Following refining, the chocolate undergoes conching, a process that enhances its texture and flavor. Large conching machines continuously mix, aerate, and heat the chocolate for several hours, allowing volatile acids to evaporate and the flavors to develop fully. Toblerone's conching process is fine-tuned to create a silky texture and a well-rounded, rich taste. Meanwhile, the honey and almond nougat mixture is prepared in a separate area of the factory. Sugar, honey, and egg whites are heated and aerated to create a light, chewy nougat. Almonds, which have been roasted to bring out their nutty aroma, are chopped into small pieces and folded into the nougat mixture. The nougat is then cooled and ground into fine pieces before being incorporated into the chocolate. Once the chocolate has completed the conching process, the finely ground nougat mixture is carefully folded into it, ensuring even distribution. This step is crucial in maintaining the signature texture and taste of Toblerone. With the chocolate and nougat mixture fully blended, the next stage is tempering. Tempering is a precise process of heating and cooling chocolate in a controlled manner to stabilize the cocoa butter crystals. Proper tempering ensures that the chocolate has a glossy finish, a firm snap, and a smooth texture. Toblerone's tempering process is carefully calibrated to achieve the ideal consistency before molding. Molding is where Toblerone's iconic shape comes to life. The tempered chocolate is poured into custom-designed triangular molds that give the bar its distinctive peaks. The molds are gently vibrated to remove air bubbles and ensure even distribution of the chocolate. After molding, the bars pass through a cooling tunnel where they are gradually cooled to allow the chocolate to set perfectly without cracks or imperfections. Once solidified, the bars are removed from the molds and transported to the quality control station. Each bar is inspected using high-resolution vision cameras, which detect any inconsistencies in shape, texture, or coating. Automated sorting systems remove any defective bars, ensuring that only perfectly shaped Toblerone bars proceed to packaging. The packaging process is designed to maintain the freshness and integrity of the chocolate. Toblerone bars are individually wrapped in foil to protect them from moisture and light, then placed into the iconic triangular cardboard cartons. High-speed packaging machines fold and seal the cartons with precision, ensuring that the bars remain securely enclosed. Following packaging, the bars are palletized using robotic systems, stacked carefully for stability during transport. These pallets are shrink-wrapped and loaded onto trucks for distribution to markets around the world. Temperature-controlled logistics ensure that the chocolate remains in perfect condition during transit. Throughout the entire manufacturing process, Toblerone maintains strict quality control measures. Each batch undergoes laboratory testing, including texture analysis, microbial screening, and taste assessments conducted by trained specialists. Data is continuously logged in automated tracking systems, allowing for full traceability of every Toblerone bar produced. Different Toblerone manufacturing facilities may employ slight variations in processing techniques depending on regional ingredient availability and market preferences. Specialty additions, such as Toblerone white chocolate or Toblerone dark, require slight modifications in ingredient formulations and processing steps. As consumer preferences evolve, Toblerone continues to innovate while maintaining the brand's heritage of Swiss chocolate craftsmanship. Investments in sustainable cocoa sourcing, eco-friendly packaging solutions, and advanced automation ensure that Toblerone remains a global favorite while reducing its environmental footprint. Through precision engineering, time-honored techniques, and a commitment to quality, every Toblerone bar delivers the signature taste and texture that chocolate lovers around the world cherish. The production of Snickers, one of the world's most popular chocolate bars, is a highly automated and meticulously controlled process designed for efficiency, consistency, and large-scale output. With its signature combination of nougat, caramel, peanuts, and milk chocolate, Snickers is produced in state-of-the-art facilities that use cutting-edge food processing technology, ensuring that every bar meets the brand's high-quality standards. From sourcing the finest raw ingredients to packaging and distribution, every step is optimized to deliver the same taste, texture, and satisfaction in every bite. The journey of a Snickers bar begins with the careful selection of raw materials. The main components include sugar, peanuts, milk powder, cocoa mass, cocoa butter, palm oil, glucose syrup, egg whites, and emulsifiers. These ingredients are sourced from carefully vetted suppliers, ensuring compliance with strict food safety and sustainability standards. Mars, the company behind Snickers, prioritizes responsible ingredient sourcing, ensuring that cocoa is ethically obtained through its Cocoa for Generations program, which promotes fair labor practices and sustainable farming methods. Peanuts, another crucial ingredient, are primarily sourced from the United States, where they are grown under controlled conditions to maintain size, flavor, and crunch. Once the ingredients arrive at the manufacturing facility, they undergo a rigorous quality control process. Each batch is tested for moisture content, purity, and potential contaminants. Peanuts, in particular, go through an additional inspection phase, where they are sorted by size and quality. High-speed optical sorting machines remove any defective or discolored peanuts, ensuring that only the best nuts make it into Snickers bars. The first major step in the Snickers production process is creating the nougat base. Nougat provides the chewy texture that forms the foundation of the bar. It is made by combining sugar, corn syrup, and water, which are heated in large industrial cooking vats to create a syrup. This syrup is then aerated using high-powered whipping machines, which incorporate fine air bubbles, giving the nougat its characteristic light and chewy texture. Egg whites or soy protein are added as stabilizers to help maintain consistency. Once aerated, the nougat is spread onto a moving conveyor belt in a continuous sheet, where it is allowed to cool and set. This process is carefully controlled to prevent the nougat from becoming too hard or too soft. Automated guillotine cutters then slice the nougat sheet into uniform rectangular portions, ensuring that each piece is the exact size required for Snickers bars. Next comes the caramel layer. The caramel in Snickers is made from a blend of sugar, glucose syrup, milk, and butter, which is heated in large stainless steel batch cookers. The temperature is carefully monitored to achieve the perfect viscosity, thick enough to hold its shape, but soft enough to provide a smooth, chewy texture. Once cooked to perfection, the caramel is poured in a controlled stream onto the nougat base. The caramel-covered nougat passes through a cooling tunnel, where it sets just enough to be firm, but still pliable. Now it's time to add the peanuts. Before being incorporated into the bars, the peanuts are roasted in industrial ovens to enhance their flavor and crunch. After roasting, they are cooled and evenly distributed over the caramel layer using precision peanut dispensers. These machines ensure that each bar receives the right amount of peanuts, maintaining uniformity across all Snickers bars. Once the peanuts are in place, the layered nougat, caramel, and peanut sheet moves to the cutting stage. High-speed rotary blades slice the continuous sheet into individual bar-sized portions. Each cut must be precise, ensuring that the caramel and nougat layers remain intact while maintaining a consistent size. The next critical step is chocolate enrobing. The milk chocolate coating used for Snickers bars is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder. This mixture is refined and conched in large machines that continuously grind the chocolate to achieve a smooth texture. The chocolate is then tempered, a process that involves controlled heating and cooling to stabilize the cocoa butter crystals. Proper tempering ensures a glossy finish and prevents fat bloom, which can cause chocolate to develop a dull appearance. At the enrobing station, the cut bars pass through a waterfall of liquid milk chocolate, fully coating them. Excess chocolate is removed using controlled air jets and vibrating conveyors, ensuring an even layer without excessive buildup. Some factories use a two-stage enrobing process, where a thin base coat of chocolate is applied first to create a stable foundation before the final. Thicker chocolate layer is added. After enrobing, the bars enter a multi-zone cooling tunnel. This tunnel gradually lowers the temperature in controlled stages, allowing the chocolate to set properly without developing cracks or dull spots. Once fully cooled, the Snickers bars emerge with a perfectly solidified chocolate coating, ready for quality inspection. Quality control is a critical component of Snickers production. Each bar undergoes a series of automated inspections to ensure that it meets strict specifications. High-speed vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, improper size, or misshapen layers. Any bars that do not meet the required standards are automatically rejected and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. Once the bars have passed inspection, they move to the packaging stage. Snickers bars are individually wrapped in plastic film using high-speed horizontal flow wrapping machines. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and packed into branded cartons using automated case packers. The final step in the process is palletization and distribution. Automated systems stack the packaged cartons onto pallets in precise formations, optimizing space for transport. These pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Snickers bars are shipped to over 70 countries, requiring an advanced logistics network to ensure that they arrive fresh and in perfect condition. Throughout the entire production process, Mars maintains stringent food safety and sustainability practices. Each batch undergoes extensive laboratory testing, including microbiological screening, allergen testing, and texture verification. The company also invests in sustainable ingredient sourcing, reducing its environmental footprint through energy-efficient manufacturing processes and eco-friendly packaging solutions. Different Snickers manufacturing facilities may employ slight variations in processing techniques based on regional ingredient availability and consumer preferences. For example, some regions may use alternative chocolate blends with varying cocoa content, while others may modify the nougat or caramel consistency based on market demands. Additionally, special edition Snickers bars, such as Snickers Almond or Snickers Peanut Butter, require modifications in ingredient formulation and production methods. As consumer preferences evolve, Mars continues to innovate while maintaining the classic Snickers taste and texture. Advancements in automation, AI-driven quality control, and sustainable manufacturing practices are shaping the future of Snickers production. Despite these innovations, the fundamental principles of precision, consistency, and quality remain unchanged, ensuring that every Snickers bar delivers the same delicious combination of chewy nougat, gooey caramel, crunchy peanuts, and smooth milk chocolate that has made it a favorite among chocolate lovers worldwide. The production of Tony's Chocolonely chocolate bars is a carefully designed process that emphasizes ethical sourcing, sustainability, and high-quality chocolate-making techniques. Unlike traditional chocolate brands, Tony's Chocolonely is dedicated to creating a slave-free chocolate industry, ensuring that every step in the supply chain is transparent and fair. From sourcing cocoa beans from cooperatives in West Africa to molding and packaging the final bars, the production process is a seamless blend of traditional craftsmanship and modern automation. The journey of a Tony's Chocolonely bar begins with cocoa sourcing. The company partners with cooperatives in Ghana and Côte d'Ivoire, regions that are known for cocoa production, but also face significant challenges related to child labor and unfair wages. Tony's Chocolonely implements direct trade practices, paying a premium for cocoa and providing additional support to farmers through training programs and financial resources. This ensures that the beans are ethically sourced while maintaining a high standard of quality. Once harvested, the cocoa beans go through a meticulous post-harvest process. Farmers ferment the beans for several days, a crucial step that develops the deep, complex flavors needed for premium chocolate. After fermentation, the beans are spread out under the sun to dry, reducing moisture content and preventing mold growth. When dried to the appropriate level, the beans are packed into jute sacks and shipped to Tony's Chocolonely's processing facilities. Upon arrival at the factory, the beans undergo rigorous quality control checks. Samples from each shipment are tested for moisture levels, flavor consistency, and potential contaminants. Beans that pass inspection are stored in climate-controlled silos to maintain freshness before entering the production line. The first step in the chocolate making process is roasting. Large industrial roasting machines heat the beans at precise temperatures, usually between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit. This process enhances the natural chocolate flavors and eliminates unwanted bitterness. The roasting time and temperature depend on the type of chocolate being produced. Dark chocolate requires a slightly longer roasting process than milk chocolate to develop its rich, bold flavors. Once roasted, the beans enter the winnowing process. A specialized machine cracks open the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both cocoa solids and cocoa butter, the essential components of chocolate. The nibs are then ground into a thick, smooth paste known as chocolate liquor. This process, carried out by industrial grinders, reduces the particle size of the nibs, creating a velvety consistency. At this stage, different chocolate variations begin to take shape. For Tony's Chocolonely's milk chocolate bars, the chocolate liquor is combined with sugar, milk powder, and additional cocoa butter to create a creamy texture. For dark chocolate, higher cocoa percentages are used with less sugar and no milk. The next step in the process is refining. The chocolate mixture is passed through heavy-duty steel rollers that grind the ingredients into ultra-fine particles. This step is crucial for achieving the smooth texture that defines high-quality chocolate. The finer the particles, the better the melt-in-your-mouth experience. Following refining, the chocolate undergoes conching, a process that enhances both texture and flavor. Large conching machines continuously mix and aerate the chocolate for several hours, allowing any residual acidity to evaporate while intensifying the chocolate's richness. The conching time varies depending on the desired flavor profile. Longer conching results in a smoother, more developed taste. After conching, the chocolate is tempered, a precise heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering ensures that Tony's Chocolonely bars have a glossy finish, a satisfying snap when broken, and a long shelf life without developing fat bloom, the white streaks that can appear on improperly tempered chocolate. Once tempered, the liquid chocolate is ready for molding. Unlike most chocolate bars, Tony's Chocolonely bars are intentionally molded in an uneven pattern, symbolizing the unequal distribution of wealth in the chocolate industry. Automated machines pour precise amounts of chocolate into these custom-designed molds, which are then gently vibrated to remove air bubbles and ensure even distribution. The molds are then transferred to a cooling tunnel, where the chocolate gradually solidifies under controlled temperatures. This process prevents the bars from developing surface defects and ensures that they retain their perfect shape. Once the chocolate has fully set, the bars are ejected from the molds and sent to the quality control station. High-speed vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or uneven texture. Any bars that do not meet the required standards are removed from the production line and either reprocessed or discarded. After passing quality checks, the bars move to the packaging stage. Tony's Chocolonely uses brightly colored, easily recognizable wrappers, each featuring bold typography and branding. The packaging process is fully automated, with high-speed wrapping machines, sealing each bar in foil and paper to protect it from moisture and contamination. The wrapped bars are then packed into cartons using robotic case packers. The final step in the process is palletization and distribution. Automated robotic systems stack the packaged bars onto pallets in a precise arrangement, optimizing space for transport. Come on, you're telling me sausages aren't your forever love? You've got to be kidding, because it's almost impossible to leave sausages untouched on the plate. As I felt you deserved to know how factories make your favorite sausages, I've managed to get inside the processing plant. Let's begin with the fresh, clean meat carefully fed into the machine, ensuring it's boneless to avoid any processing issues. It's divided into portions to constantly send them into huge grinders bit by bit. This step-by-step approach guarantees that the meat is perfectly processed without any lumps, achieving perfection in every bite. As they choose to give the sausages a perfect blend and mouth-watering flavors, they work on the mixed meats, which involve frozen meat too. Just to inform you, freezing the meat at low temperatures for a specific duration kills parasites and bacteria, crucial for the safety of sausages. This process not only enhances their shape to perfection, but also extends the shelf life of these savory treats, giving them a smooth, buttery texture. You can see how beautifully the entire meat is shredded and chopped. Buckle up because it's going to be rich and smooth, just as you like. In the next step, a mix of spices or herbs is added for great flavor. It's all in the blend of spices and meats. Some are spicy with a kick of pepper, while others are mild, so they will cook perfectly. Ice adds moisture to the mixture, so it's added in small amounts to help achieve the desired juiciness and consistency in the final product. Keeping the mixture cold makes it easier to mix the ingredients evenly, ensuring a consistent flavor throughout the sausage production. You can see how the frozen meat and spices blend smoothly into a soft, even texture after being expertly ground, along with a bunch of ice being added in intervals and some other runny but important ingredients. Here come the eggs, a lot of them. These automatic machines are responsible for cracking the eggs and separating the yolks from the whites, because only yolks are needed. This isn't a challenge, thanks to these machines. The yolks are then whisked into the mixture to ensure a lump-free blend. This perfected mixture is then seamlessly integrated into the ground meat, crafting delicious sausages packed with savory flavors and made in countless delicious varieties. Sausages are a favorite food around the world. Now comes the next step, preparing the natural casing for sausages. It's soaked in cool water for at least 30 minutes to several hours, ensuring it's thoroughly washed to remove any residual salt and all prepared. It's moisturized with a touch of water to prevent drying and maintain its perfect form. The sausage mixture is carefully piped into the machine, ensuring it's shaped into specific sizes. See how these sausages emerge, perfectly shaped and glistening with a shiny finish, ready to delight your taste buds. Check out this natural casing holding your favorite sausage material. Just look at that consistency. After cutting, these sausages are coated with various flavorful sauces and undergo a pre-drying procedure for several hours. Your favorite sausages are now undergoing the crowning smoking process, which helps them gain that delicious flavor. This process also serves several purposes, which we'll expose in a bit. Finally, they move to the post-drying stage, where the changing color enhances their delicious appeal. In the next stage, they are prepared with natural sausage casings, evenly and securely tied to avoid air pockets. Stainless steel hooks or wooden rods are used to hang the sausages, ensuring they are evenly spaced to allow for adequate airflow between each one. This thoughtful arrangement ensures that during the drying and smoking process, each sausage receives consistent exposure to smoke and air, enhancing flavor and texture uniformly. Smoking sausages serves two main purposes. First, it adds a delicious smoky flavor that many people love. Secondly, smoking helps extend the shelf life of sausages. The smoke contains natural compounds that act as preservatives, helping to prevent spoilage and bacteria growth. This means sausages can last longer without the need for artificial additives. So yeah, smoking isn't just about taste. It's a smart way to preserve and enhance one of our favorite foods. After completing the drying process, the hanging sausages are carefully removed from the hooks or rods. Their color has transformed beautifully during this stage. Next, they are swiftly fed into a high-speed robotic system, where they are separated with precision using powerful air pressure. As they are getting ready, just imagine them perfectly tucked into a warm bun with mustard and onions. My goodness, I can barely focus now. Of course, how could we forget about the packaging? Each sausage is packed as carefully as it was crafted. They are placed in preset quantities in their desired boxes. Watch powerful hands tirelessly prepare the casing for sausages, but there's also a little friend that helps to fill up these casings automatically. Now they shape each sausage using precise measuring instruments and then carefully mold them by hand, preparing them for the drying process. For drying, each sausage is carefully hung one by one on iron rods, ensuring they attain the perfect shape and form. After a precise inspection to ensure top-notch quality, these savory treasures hang to dry and cure in a controlled environment, where their flavors deepen and mature. Maybe next time, before grabbing another bite of sausages, you will remember and appreciate the effort behind making those delicious sausages you eat. You might know those cheese cravings that refuse to quit until you take that first bite. Who's nodding along with me on this? If you can't resist grabbing a slice, even in the middle of the night, maybe we're in this together. Let's get straight to the stables, where hundreds of these beauties are kept safe and sound. And when I say safe and sound, I mean it. If you're wondering whether these cows are wearing yellow-colored earrings, no, in fact, they've got their number tags, so no cow is left unattended, and every beauty gets equal protocol regularly. You've probably heard that only healthy and happy cows provide nutrient-packed milk, so their diet and cleanliness are top priorities for farmers. Hey, stop. Where are y'all going? Oh, the milking facility. Let me show you around. This is the basic milking process that involves a bit of manual help, like installing the automatic milking devices and noting the required time to remove them immediately. Does that seem like a hassle to you? Worry not. I've saved 100% milking automation for you guys, so stick around until I get permission to show you the most secure and advanced milking facility. You might wonder how these cows cooperate so well. It's quite clear. Each cow is lured to its spot with its favorite food as positive reinforcement. The milking devices literally take a few seconds to detect the milking spots and connect to them automatically. Literally, no human hand is needed. This high-tech milking process can be completed in just 5 to 7 minutes, whereas hand milking can take much longer. Did you know that dairy cows are typically milked 2 to 3 times a day, ensuring a steady supply of fresh milk? It's true. Automated machinery offers immense benefits, yet many still prefer the old-school manual methods. These devices are directly connected to individual drums, where the milk is automatically collected without any outside contact, straight from cows to the drums. One major perk of large-scale milk production in factories is that human effort, once solely for milking, is now redirected to even more valuable tasks. Some advanced technology factories even use sophisticated milk meters to tally up each cow's milk production with high precision. After milking, an automated cleaning system sanitizes the equipment to maintain proper hygiene, keeping things squeaky clean. Large-scale production has now reached sky-high levels as we step into this magical world of mozzarella cheese. Every move follows precise guidelines. First, the fresh milk is poured and pasteurized to make it ready for cheese production, and of course, to kill any possible harmful bacteria present. This man carefully adds rennet, an enzyme, and some starter cultures like lactic acid bacteria to prepare the healthy curd for cheese processing. Rennet helps to coagulate the milk, while the bacteria acidify it, keeping the desired thick consistency of the curd they need. Once the curd reaches the right consistency, they use huge sieves, or special knives, to cut the curd into smaller pieces. This will help the curd to separate from the whey easily. The more it rotates, the more whey gets separated, giving the paramount cheese curd. It's getting easier to transfer into larger pots for further processing. Once collected into bigger, wide-open pots, these curds need to be cooled to room temperature, so it's easier to process the cheese curd further. It's good to test any step beforehand rather than improvising the whole thing at a bigger level. time to shred the large cubes of solid curd into smaller chunks. If you've ever made mozzarella cheese at home, you'd probably know why this step is important, except now it's on a larger scale. As soon as the curd cubes are shredded into fine, smaller chunks, hot water is added through pipes to make the curd flexible for kneading. Yep, it's the most fascinating part of the entire cheese processing. This spinning or kneading is the most difficult part of the process because if you don't soften it just right, the mozzarella won't turn out to be the best you've always loved. But thanks to those experts, they can handle bulk production with so much care, never compromising on our stubborn taste buds. Once the cheese is kneaded perfectly, they just need to make small balls of cheese, and the machines will collect them automatically. Look how conveniently those mini cheese balls come out of their dedicated zones. Using a constantly running water stream makes the process way smoother. Let me walk you through some very curious stuff. Did you know that as cheese ages, it naturally changes its texture? Yes. With time, its moisture content decreases, resulting in a firmer, more crumbly texture that enhances its overall appeal. Some cheeses even develop a protective rind during aging, which not only preserves moisture, but also adds depth to its flavor profile. Unlike traditional manual methods, where each step requires significant human effort and time, automated systems streamline the process, allowing for faster production rates without compromising the integrity of the final product. This results in fresher, longer-lasting products that retain their flavor and texture until they reach consumers' tables. The right pH level ensures curds achieve their perfect texture, whether silky smooth or delightfully firm and stretchy. Who doesn't love vibrant colored ice popsicles in the summer? A special mixture for ice pops is poured into molds of specific shapes and left to set with sticks neatly in place. Of course, its appeal goes beyond just being a treat for kids. After a short time, all it takes is a cool temperature, and they fit perfectly into their molds. Recent research in the United States reveals that bulk ice pop production in factories boosts efficiency by up to 50%, cutting down on production costs while ensuring consistently high-quality treats for everyone to savor. Efficient packaging ensures that the ice pops are properly protected during transportation and storage, maintaining their quality and preventing any damage. Freshly harvested potatoes arrive at the factory, where the chosen potatoes are gently loaded onto a conveyor belt. This belt carries them smoothly into the heart of the washing area, where a steady stream of water showers over them. This stage is crucial for maintaining the potatoes' hygiene and ensuring they are free from any contaminants that could compromise their quality. After the initial rinse, the potatoes enter a brushing and scrubbing phase. Here, soft brushes mounted on rotating cylinders gently massage the potato skins. Once thoroughly washed, the clean potatoes proceed to a drying stage. This step is typically 2 in 1. They dry naturally while moving ahead toward further processing. Peeling, obviously. The potatoes enter the automatic peeling station, where abrasive rollers gently remove their skins. They are then moved to large choppers, which cut the potatoes into uniform chunks. This factory is truly multitasking, as it doesn't only prepare potatoes for silky smooth mashed potatoes, but also for various cuisines. For example, special cutters slice the potatoes into wedge shapes, so potato wedges are no longer a hassle. While some peeled potatoes are sent for further examination, experts pass the good quality potatoes to be cut into halves and packed immediately. Yes, because we can't wait to show you the satisfying process of making mashed potatoes in bulk. To prepare the creamiest and most flavorful mashed potatoes, the experts boil the potatoes right on the spot. While in many households, like mine, where spare time is an issue, already boiled potatoes, cooked a day or two before, are used to make mashed potatoes quickly. These experts know never to compromise on taste. When the potatoes are perfectly boiled, the unnecessary water is drained, and the steamy hot potatoes get their royal treatment in a smooth blender. As the main character, the potatoes are blended while butter is added bit by bit to ensure a thorough and creamy mix. Talk about creamy. To make mashed potatoes even creamier and dreamier, a specific amount of milk is poured in and mixed all over again. This gives the mashed potatoes a smooth texture and perfect consistency, making you crave more. And there you have it. The superheroes have undergone the ultimate transformation and are ready to be served as a delicious creamy side dish or main course. It totally depends on your taste. Never underestimate any small element, even if it's a nozzle, pouring equal quantities of mashed potatoes into every batch. It was truly a team effort. One of the famous international frozen pizza companies is on a mission to create the most delicious pizza ever. They start off with smooth, fluffy dough, which is balled up and spread out neatly in thousands of pizza pans for quick and partial baking. Meanwhile, the pizza sauce is being prepared and spread neatly over the baked dough by automatic machines. No manual help needed. You know cheese could go bad, so before it ruins the entire pizza party, they check it for top-notch quality beforehand. Once it's deemed good enough, the crushers shred entire blocks of cheese and sprinkle it over thousands of pizzas to give them a perfect texture. Some more cheese slices are neatly added on top. Finally, they pour on other sauces and ingredients, preparing the pizzas to be frozen right away. The pizzas are covered with a transparent food sheet and packed into boxes to keep them fresh and preserved. These machines don't demand appreciation, but they deserve it, don't they? So hit the like button for the sake of these and many other robotic machines working tirelessly to give you perfect outcomes every time. Just check out how this ordinary looking dough transforms into perfect buns with a single push of a button. Yes, this entire automation doesn't involve any manual help. Once balled up and rested in their dedicated pans, these fluffy dough balls rise for a couple of minutes. The vacuum then blows off extra crumbs, giving them a neat, finished look. When the buns are perfectly baked, they're all set to get dressed. If you like our video, please give it a thumbs up and support us in creating more content for you guys. As I always say, you're all we have. Look at those nozzles pouring delicious jam onto each half, giving you the best mouth-bursting flavors. Let's indulge in the golden sweetness of honey candies, where each bite is a taste of pure honey. Here, the process begins with a blend of pure honey and other required ingredients, transformed by super smart rollers into a thick, delightful mixture. This mixture is rolled out consistently and kneaded thoroughly. Just look at that consistency. It's so rich and smooth. It's amazing how these machines continuously knead the candy material without taking a break to ensure it perfectly meets your standards. Now, the little automated machines ensure that each candy gets the perfect and desired shape and cut. As the candies move through the production line, quality control sensors monitor each piece. These sensors check for consistency in size, shape, and texture. Once the candies have cooled and set, they are transferred to the wrapping machine. This machine wraps each batch of candies in protective packaging, keeping them fresh and preventing them from sticking together. Each pack holds around 9 candies, loved worldwide for their pure taste and eye-catching packaging. The wrapped candies are then packaged into boxes using large-scale packaging machinery. This step prepares the candies for distribution, ready for shipping. Stop messing with your sweet tooth. Nature. Not everything sweet is worth tasting. So grab only your favorite honey top biscuits that are rich in taste and super affordable. Do tell me when you find one. Jelly Belly candies are true gummy delights that are crispy on the outside, but burst with mouthfuls of liquid flavor the moment you munch them. First, the ingredients are mixed together in a large machine until the mixture is just right. Once the mix is ready, the machines pour it into molds to shape the candies. Now it's time for their rest, which doesn't take too long. Once the candies cool down, they're removed from the molds and spun in a special machine to ensure they're the perfect size, shape, and texture. This process creates countless candies with tons of flavors to try. With so many different flavors, there's a Jelly Belly for every mood, and you're sure to find one you love. They ensure everyone can enjoy their favorite candy flavor and have a great time eating it. With so many different tastes, from fruity to sweet and everything in between, you'll never get bored. These treats turn snacking into a fun journey, letting you discover your new favorite flavor with every bite. When it comes to comparing super smart machines with human hands, robotic machines take the cake. They do everything super fast, perfectly, and with precision. Like right now, these machines are helping to create thousands of baked crusts to be filled with sweet and savory sauces for bakeries and restaurants. Loads of fresh meat are brought in and fed into a super fast chopping machine. This machine cuts it all into equal-sized pieces and neatly packs them into cans. Each tin is sealed tight and labeled with robotic precision in very little time. Creating perfect and smooth dough is a challenging task for human hands. However, for these magical machines, shaping dough into equal-sized pieces is no big deal. Once the dough is ready, the balls are prepared and undergo a smooth waffle-making process. This machine rolls and bakes the dough balls simultaneously, ensuring no additional time is wasted, with the results being absolutely flawless. In today's busy times, sandwiches are considered the perfect meal. Just pair one with a cup of coffee or tea for an easy energy boost. Advanced machinery prepares these sandwiches automatically, taking less time than you can imagine while packing a full energy punch. Different fruit flavors become uniquely delicious when transformed into sweet delights like candies. Robotic machines ensure these flavors are smooth and their textures consistent, making the taste incredibly delicious and enhanced. Robotic systems cut, shape, and create perfectly equal-sized candies in bulk in the blink of an eye. The candies are then moved to be wrapped in beautiful, eye-catching wrappers, ready to be enjoyed. Watch as these machines make the perfect donut-shaped sponge cakes, which are later topped and dipped into creamy, rich chocolate. Each donut is uniformly crafted and beautifully finished. To enhance the creamy flavor, a drizzle of chocolate syrup is added on top to make every bite a delightful experience. Once finished, they move on to the next process.